right, this is CS50, and this is already week 8. And up until now, of course, in so many of our problem sets, like we've been writing command line code, like a black and white terminal window, and everything is very keyboard-based, very textual. But of course, like the apps that you and I are using like every day are in the form of a web browser and on our phone. And so today, and really for the rest of the semester, we now transition to using all of the building blocks that we've been accumulating over the past few weeks, but to redeploy them in the context of web apps and, for your final project, for instance, if you so choose, even mobile apps as well. So today, we're going to understand how the internet that we use every day actually works. We're going to introduce you to a language called HTML, which is the language in which web pages are written, a language called CSS, which is the language with which web pages are stylized, and then lastly JavaScript, which of those is the only actual programming language. But even though we'll spend quite little time on it, you'll see syntactically and functionally it's very similar to C, to Python, and languages indeed that have come before. All right, so we use the internet every day. So what exactly is it? Well, in the simplest form, like we've got networks in the world, and networks are interconnections of computers, whether with wires or wirelessly. You have a network at home nowadays for the most part. You certainly have a network on a campus like this. In corporations, you have networks, so interconnections of computers. As soon as you start networking the networks, if not networking the networks of networks, you have, in effect, the internet. So this global interconnection of computers, servers, devices, and so many other things, literally nowadays, that we take for granted every day. But how does it actually work, and where did it come from? Well, if we rewind to like 1969, the internet, in its original form, really something known as ARPANET for the Advanced Research Projects Agency, project from the Department of Defense that was really designed to interconnect what limited supercomputers we had back then that were otherwise geographically inaccessible to so many researchers and others. The internet, or ARPANET, really just looked like this, with UCLA and just a few other nodes, so to speak, interconnected somehow. Just a year or so later, did we have Harvard and MIT and others on the East Coast. And if we fast forward now to today, of course, we can find and route data most anywhere in the world. And in fact, the world is now filled with these things that are called routers. A router is just a computer, a server, that routes data up, down, left, right, geographically. And of course, in the real world, it might go out this wire here, out this wire here, out this wire, or out this wire. And in fact, just to make more real what we're about to be talking about when we talk about networks of computers and eventually the internet, we engaged some of our teaching fellows over the past few years to perform a little skit of sorts for us using Zoom, if you will, whereby each of the teaching fellows, or humans you're about to see, consider them as representing a router, a device on the internet whose purpose in life is to route data. And what they're routing is what we're going to start calling packets. Packets of information, which metaphorically you can think of as just like a little white envelope like this that we use to send things via snail mail, via the US Postal Service, or beyond that internationally. So I give you, in just 60 seconds or so, what it means to send a packet on the internet, for instance, from Phyllis in the bottom right-hand corner to a familiar face, Brian, at top left. If we could dim the lights, if only to be dramatic. Thank you. Sure, we can clap for that. And we actually should clap for that, because you're seeing the sort of final version, which looks kind of perfect, but they were all smiling and clapping because it took us so many damn takes to like actually get the coordination of that correct. But for now, assume that it was in fact correct. But notice what's among the takeaways from even that little skit is that the packet, the envelope from Phyllis to Brian, could have taken any number of paths. It could have gone up and then to the left. It could have gone left and then up. It could have zigzagged and the like. And that's actually representative of how the world now looks because of so many wires and so many wireless connections. There's actually a lot of ways that data can travel from point A to point B. And it turns out it's not even necessarily going to be the shortest difference. It might be the least expensive distance. Or perhaps just the result of how some humans or how some servers have automatically configured the routes to get from point A to point B. So let's consider how the data is actually getting there. So long story short, all of those routers, and indeed all devices on the internet, including the ones in your pocket or on your laps, speak a language, more technically a protocol, nowadays known as TCP IP. And this is actually a pair of protocols, which is a set of conventions that governs how computers behave on the internet. In the human world, we have protocols as well. For instance, when I meet someone for the first time, I very often instinctively sort of extend my hand, just sort of hoping that they too will extend their hand and shake. And that's a human protocol in that it governs how two people, in that case, intercommunicate. Well, servers have the same kinds of protocols, but it's all text-based or bit-based instead of course, physical. But TCP and IP are two different protocols that solve two different problems. And let's focus on the last of them first. So IP, short for Internet Protocol, is simply a protocol that decides to give all of us a unique address in the world. In other words, there are these things called IP addresses. It's a numeric address that literally every computer in the world has in order to uniquely identify it. Case in point, in the real world, we have addresses too. For instance, in this building here, Memorial Hall, we're at 45 Quincy Street, Cambridge, Massachusetts, 02138, USA. And theoretically, that unique identifier should get an envelope in the physical world to this location from any other in the real world. IP, as applied to the internet, just means that similarly, do devices, Macs, PCs, phones, and everything else on the internet have a unique identifier as well, known as an IP address. It's a number, but it's typically formatted in dotted decimal notation, so to speak. So it's something dot something dot something dot something. And just as a bit of trivia, each of these number signs represents a value from 0 to 255. So there are 4 such values, apparently. And just doing some quick week 0 math, if each of those values can be 0 to 255, how many bits is an IP address, presumably? So 8 bits per number, and how many was this? So 32 bits, because if you're counting from 0 to 255, well, it's 256 total possibilities. That's 2 to the 8th, which means 8 bits, 8 bits, 8 bits, 8 bits. So IP addresses are 32 bits. Little trivia that's germane only insofar as it does kind of limit how many total devices we could seem to have in the world. If you've got only 32 bits, how high can you count, roughly? So 2 to the 32nd power, which we've generally ballparked as 4 billion, which is to say you can have 4 billion devices total, it would seem, on the internet, which is a big number. But there's also a lot of humans nowadays. And odds are most everyone in this room has at least 2 devices to their name, maybe a phone and a laptop with which you're taking the course, maybe even more devices, thanks to the Internet of Things, like smart home devices. We have so many IP addresses being assigned to things. So long story short, the world is gradually transitioning from this version here, IPv4, to IPv6, which instead of using 32 bits is actually using 128 bits, which is crazy large and gives us more than enough IP addresses for the foreseeable future. To be fair, we've been talking about this for like 20, 30 years, transitioning from v4 to v6, and it's still gradually in motion. But for simplicity in the class and in general, we'll still use IPv4, if only because it's a little easier to wrap your mind around. Now, this is admittedly a pretty arcane diagram, but this is the diagram, ASCII art, if you will, that's in the official specification of what we mean by an IP datagram. More colloquially, this is what a packet actually looks like. Now, what are we looking at? Well, you're just looking at like a grid of bits. So this here represents 32 bits total, where this is bit 0, and that's bit 31, 0 indexed, all the way over there. And then each row represents 32 more bits, 32 more bits, 32 more bits, which is to say, anytime a computer, like Phyllis, sends an envelope of information on the internet, it contains at least this information. A whole bunch of bits broken down into bytes. Now, the only ones we'll really care about today are this one here, source address, which is to say when Phyllis sends that packet, she writes her source address, her IP address, something dot something dot something dot something on the outside of the envelope, so to speak. And she also puts Brian's IP address, whatever that is, something else dot something else dot something else dot something else on the outside of the envelope as well. There's a whole bunch of other bits involved which are useful, but we'll wave our hands at those for today. But that really speaks to what's actually happening. And if we do this metaphorically in the real world, it's kind of like taking out that envelope. And for instance, if Brian's IP address is 1.2.3.4, for the sake of discussion, Phyllis, in advance of our filming that bit, would have written something like 1.2.3.4 in the middle of the envelope, just like we would in the real world. But presumably, she wants Brian to be able to reply, to acknowledge receipt, or send his own message. So she's also going to put her IP address, for instance, in the top left corner of the envelope, 5.6.7.8 for the sake of discussion, so that Brian knows when he writes out his own packet of information how to actually, or to whom, to reply. But at the end of the day, it's all just bits being sent in a specific pattern, and there is formal documentation as to the order in which all of those bits will actually be sent out on the wire or wirelessly. So in short, IP ensures that all of us have unique IP addresses via which data can go from us or to us. But that's only one problem. Nowadays, of course, servers can do so many other things. They can do email and chat and video conferencing, game servers, and who knows what. And it would be nice if a single server certainly could do multiple things. And in fact, that's very much the case. Single servers nowadays, and a server is just the term of art for a computer used to serve information to other people. By contrast, our laptops, our desktops are generally clients because they only serve one of us, not multiple people. But these are just terms of art describing, at the end of the day, still computers. IP only ensures that we can uniquely address computers on the internet. But there's another protocol in TCP/IP, namely the TCP portion, that allows computers to uniquely identify services that they're offering to the rest of the world. So for instance, TCP allows a computer to distinguish whether it has received a packet that's an email, or receive a packet that's a chat message, or a piece of a video conference, or the like, which is to say there's more than just IP addresses on the outside of these envelopes. There are also what are called port numbers as well. Similarly, numeric values that are usually in the range of like 0 to 0 on up in the low thousands, and they're standardized. For instance, if you are requesting a web page using http:// with which all of us are presumably familiar, unbeknownst to you, on the outside of the virtual envelope that your computer subsequently sends is the port number 80. Because when the server receives that, it knows, oh, this human is requesting a web page and not, for instance, their email or something else. Or nowadays, if you're using HTTPS, where the S denotes secure, in the URL, you're actually using port 443, which is just an arbitrary number that a bunch of humans in a room decided on years ago to standardize what goes on the outside of an envelope. So just to be more clear then, when Phyllis is sending a request to Brian, and if Phyllis, for instance, is the client, just a human using a computer, and Brian in this story is now a web server, better yet, a secure web server that's somehow encrypting or scrambling the information to keep it secure, well, on the outside of this envelope, after Brian's IP address, which was 1.2.3.4, Phyllis is also going to write the number 443, so that when Brian receives and opens this envelope, he knows what he's looking at, a request for a web page and not an email or a chat message or something else. Moreover, we can continue the story just a little bit further. Phyllis also writes on the envelope not only her IP address, 5.6.7.8, but some number as well in that top left-hand corner, whatever it happens to be, which is a port number via which Brian can reply to her. In this way, Phyllis can, in effect, have multiple tabs open, be using Zoom and some chat software or something else, running multiple programs on her computer, and the internet packets are all coming in, but her computer knows to which tabs or applications those packets belong. So if you really want to geek out, here's what this thing looks like. This is just the sequencing of bits for TCP as well, which is to say, in addition to the dozens of bits we looked at a moment ago that standardize what IP is putting on the outside of the envelope, TCP is adding 16 bits that specify a port number, which means you can indeed have tens of thousands of possible port numbers, a destination port number, and a bunch of other stuff, including this so-called sequence number, which happens to be a 32-bit value, which is actually pretty important because quite often when sending messages on the internet, they're pretty large. And it would be nice if one person downloading a big image or one person downloading a movie or streaming a movie doesn't mean that no one else on the internet can do something else at that moment in time. So for the sake of discussion, suppose that this very happy cat here is a very large JPEG, for instance, a very large graphical file. It would be nice, let's say, that if Phyllis is trying to send or receive an image as large as this, it's not just in one massive envelope that's going to prevent a whole bunch of other users from similarly using the internet at that moment in time. So at the risk of a bit of heresy, we can actually tear this cat in half and fragment it, really. And then inside of Phyllis's envelope, or equivalently Brian's reply, depending on where this cat is coming from or going to, part of that cat can go in this envelope. And now, say in the bottom left-hand corner of this envelope, Phyllis Or Brian could write the sequence number in question, 1 out of 4, 2 out of 4, 3 out of 4, 4 out of 4, so that when this and hopefully the other packets arrive at their destination, the recipient's computer can check, OK, this was a really big file in this case. Do I have all of the parts? Yes, it can be inferred from the so-called sequence number, which we've represented there in that memo field of the envelope. There's a bunch of other stuff that can go on here, too, including prioritization of data as well. But ultimately, TCP just allows servers to handle multiple types of services and also allows it to receive data reliably. Because if, for instance, a recipient only gets 2 out of the 4 packets or 3 out of the 4 packets, the fact that there's a sequence number involved is enough information for that recipient to say to the sender, hey, I'm missing 1 or 2 or 3 or more packets. Please resend them. So in short, TCP guarantees delivery by just doing some bookkeeping on the outside of these envelopes. So in short, IP allows us to uniquely identify computers, and TCP guarantees delivery and allows us to multiplex, so to speak, among multiple services on the same device. Questions on this jargon thus far? Because today's filled with acronyms, unfortunately. Questions on IP, TCP, or anything else? OK, so seeing none, as promised, let's do yet another acronym. So it would be pretty tedious if Phyllis and Brian and all of us humans had to write actually IP addresses into our browsers when visiting websites. And in fact, most of us never do that. Instead, we go to google.com or harvard.edu or actual domain names, so to speak, which were so much easier for us humans to remember than these arbitrary IP addresses that are either automatically assigned to computers or manually configured by humans configuring servers. But there's another acronym in the world, and there's another technology used on the internet, namely DNS, for Domain Name System. And this is just a certain type of server that every home has, even if you didn't know it, every campus has, every company has. There's so many DNS servers around the world, but their purpose in life, quite simply, is to translate what you and I know as domain names, like google.com, harvard.edu, and the like, into their corresponding IP addresses. And so in short, inside of these DNS servers are essentially like a 2-column table or spreadsheet, however you want to think about it, whereby here's all of the domain names in the world, here are all of the corresponding IP addresses in the world. And so when your Mac or PC or phone being used by you is trying to access google.com or harvard.edu, that device, certainly when it's first booted up, has no idea what the IP address is for that server. It's not the case that Apple or Google are pre-installing billions of IP addresses inside of our devices, but your device is smart enough to ask the local network at home, on campus, or at work, well, what is the IP address of google.com? What is the IP address of harvard.edu? And then what your Mac, PC, or phone actually do upon getting that answer from one of these local DNS servers is it writes the corresponding IP address on the outside of that envelope. So it's a wonderfully useful service that just makes the internet more useful for you and I to use because we can use names instead of IP addresses as well. Technically, these things are called fully qualified domain names. Where do they come from? Well, some of you might actually have your own personal website. You might have gone through this process. It's actually not that hard to get your own domain name. You can go to any number of what are called internet registrars and pay them some money. And it's essentially on a rental basis. So you rent a domain name for a year or maybe 3 or 5 years at a time, and they can automatically bill you. The domain name might be as little as $1 per year or thousands of dollars per year, depending on whether someone has scooped it up and is maybe squatting or the like. But all you do ultimately is pay someone money, and they give you the rights to use that domain name. And then what you do technically is you configure some DNS server somewhere in the world to know what the eventual IP address is for your server that's going to serve up your domain name's web pages. And long story short with DNS, I say that you have one in your home and on your work and on your campus because it's a very hierarchical kind of structure. Like there is out there somewhere these so-called root servers that essentially know what all the IP addresses are of all of the .coms, for instance, or all of the .edus or the like. But my Mac doesn't know that. And so my Mac might actually ask that root server, what is that IP address? But in more efficiently, my Mac is better still going to ask the local network first. When I'm at home, it asks my home DNS server, which is built into the little home router that you've got somewhere in there. Or if you're on campus, it asks Harvard's DNS server. And this whole design is recursive, to borrow a term from a few weeks ago, in that if my computer doesn't know the answer, what's the IP address for this domain? If Harvard doesn't know the answer, it eventually gets escalated to those so-called root servers, but then cached, that is remembered by all of these other DNS servers along the way. So it's a very elegant hierarchical design, but at the end of the day, it's just doing this. It's a big cheat sheet of domain names to IP addresses, and the server is responding for us. All right, one more acronym. So how do I know what my Mac's IP address should be? How do I know what my phone's IP address should be? How do I know what the IP address is of the DNS server of whom I should be asking any of these questions? How do I know the IP address of the router to whom to hand my data off to? Like, there's a lot of assumptions built into the story we've been telling. And the answer is, unfortunately, yet another acronym. DHCP is the solution to all of those problems. And it wasn't always. Back in my day, we used to have to manually type in what our computer's IP address was based on what some human told us it would be. We had to type in our DNS server, type in our router address. But now DHCP is just yet another server running in your home network, running on campus, running in your corporate network, whose purpose in life is to answer questions of the form, what is my IP address? Which is to say, when you boot up your Mac, your PC, your phone for the first time, it essentially broadcasts a message like, hello world, what's my IP address? And hopefully, there's one such DHCP server on that local network, wired or wirelessly, that will respond based on how Harvard or Comcast or Verizon or someone at home has configured it to tell you what your device's IP address is, what the IP is of your local router, what the IP address is or are of your DNS servers, and the like. And so this is why things just work nowadays once you've connected to like a Wi-Fi network or physically plugged in. Dynamic host configuration protocol didn't always exist. Wonderful that it now does. All right, enough sort of outside of the envelope stuff. Everything else today will be a deeper dive inside of this envelope to look at what actually are the messages that we are sending, receiving, how are you structuring the web pages and designing everything that comes back from the server to the client. And let's dive in then to this acronym, HTTP, which you've been typing for years or seeing for years, even though you don't really have to type it anymore because browsers just assume that this is what you want. But HTTP is another protocol, Hypertext Transfer Protocol, whose purpose in life is to request web pages and receive web pages. As a protocol, it just standardizes like what goes inside of that envelope when you're trying to use the web. There are different protocols for email, different protocols for Zoom, different protocols for Discord, and any number of other internet services. We'll focus predominantly today on HTTP, which happens to use ports 80 and 443, among others, as we saw. So let's see what HTTP is all about, or HTTPS, the corresponding secure version thereof. So here is a URL, canonical URL, in that it has a whole bunch of components. Let's consider what some of the jargon is that we're going to start taking for granted. So if you go to https://www.example.com/, you are implicitly requesting the root of that website. Root just means the default directory, the default folder, if you will. And that's what the yellow highlighted slash here just means, like, give me the default web page. Technically speaking, what you're going to receive in your browser, unbeknownst to you, is an actual file. By convention, it's a file called index.html, maybe index.htm, or any number of other files. But it would be pretty stupid if we, as humans, all had to type out the actual file name that we want. So the server, by default, is just going to return you the root of the website. If, though, you're inside of a folder, or you do actually click on a link that leads you to a file, you might very well have, at the end of this domain name, a full path as well, which might contain 0 or more folder names and 0 or one file names as well. In fact, it could be explicitly file.html or /folder/file.html. You've probably seen thousands of these over time, even if you haven't really given it much thought. So we, today, onward, will be creating all of this stuff here, but we need to understand what's going on to the left, too. So here's the so-called domain name, or more properly, the fully qualified domain name. And it has a few different parts, too. So this is technically the domain name, as we all refer to it. Something.something. .com means commercial. And that .com is more specifically known as a top-level domain, or TLD. Back in the day, there were only a few of these, .gov, .com, .net, .org, .edu, and a bunch of others. Now there's hundreds, if not thousands of them. Many of them aren't really used prominently in the wild, but there are some not on that original list, like CS50 uses .io. a lot, which doesn't mean input, output. It's actually a 2-letter country code that has been essentially rented to us and anyone else using that same TLD, because in the English-speaking world, .io actually sounds kind of cool. It kind of connotes, indeed, input and output. .tv is another one that actually belongs to a country, but in fact also sounds like in English television, and so that too has been used as well. But in general, there are top-level domains like these. Some of them now are full words. Some of them are 2 characters denoting they belong to a country. They are the sort of top-level, indeed, categorization of all of these websites. Meanwhile, many URLs, but not all, also have something to the left of the domain name known as a host name, which technically speaking refers to the name of the server that you're requesting specifically. It doesn't have to be literally one server. www can refer to dozens of, hundreds, thousands of servers. Indeed, if you go to any popular website like gmail.com or the like, even though you only have one domain name, somehow or other technologically, it is referring to clusters of hundreds or thousands of servers that ensure that they can handle all of the customers that might visit that site. And then lastly, there's this, the scheme or the protocol in use specifically. And for our discussion today, it's always going to be HTTPS, which is ideal because it's secure and encrypted somehow. But it can also be, indeed, HTTP://. So that's it. Like, that's just the jargon with which you should be familiar when it comes to URLs like these. And what we'll be doing today is actually creating content that lives at URLs like that and serving it up to us. But what do the messages ultimately look like that are going inside of these envelopes? What the URLs are doing are just getting us to the right place. But how do we express in some form of code that we want this file.html from this server using encryption in this way? Well, inside of the virtual envelopes that Phyllis was sending to Brian and he would have ultimately sent back to her are messages that look like this. Get, post, and a bunch of other verbs, if you will. So HTTP supports a bunch of operations or verbs, namely get, post, and a few others. And it was indeed the first of these that Phyllis would have put inside of her envelope initially in order to get a web page like a cat from Brian. Specifically, inside of the envelope, she would have had a textual message. It's not code per se. There's no functions or loops or variables or anything like that. It's a protocol, just in the sense that humans years ago standardized what messages should appear inside of those envelopes if you want to get a web page from a server. So for instance, if Brian in this story is now suddenly harvard.edu, specifically www.harvard.edu, Phyllis's envelope would have contained a message saying get in all caps, / if she just wants the root or the default page from Brian's server, the version of HTTP that she's using, for instance, version 2. And she would also specify, just in case Brian is multitasking and serving up websites for different domain names on the same physical box, which actual host that she wants, and maybe a bunch of other lines as well. And hopefully, if all goes well, Brian would have responded with an envelope of his own containing an HTTP response in answer to her HTTP request. And Brian's envelope would have contained a textual message that just confirms what version of HTTP he's using, a status code, which is an arcane number that just indicates, in this case, that everything is OK, all is well. And he would specify the type of content he's sending back to her in his own envelope, because it could be HTML, more on that later today. It could be a JPEG. It could be a GIF. It could be any number of other file formats. And this is just a hint to Phyllis's browser as to what's going to be inside of that envelope she is getting back within her browser. And then maybe a bunch of other stuff as well. So even though some of these details, like these underlying implementation details, might visually be new to you if you've never really thought about it, turns out we, as aspiring programmers, can actually see and poke around with these building blocks and ultimately today take advantage of them. So you're about to see a program that's called curl, which stands for connect URL. It's installed in Linux systems like CS50.dev. It also comes with Macs and PCs quite frequently, or you can easily install it. And essentially, it's a headless browser that allows you to pretend to be a browser and grab the response from a server by actually sending the contents of an envelope like this. So for instance, if I want to pretend to be a browser and request harvard.edu, I can type this in my CS50.dev terminal window. And let me go ahead and maximize its size and do the following. Curl -i, which specifically is only going to show me the headers, the text that we were just talking about, and it's not going to send any of the contents of Harvard's website. curl-I https://www.harvard.edu/. So if I were typing this into a browser, I would actually see Harvard's homepage. In this case, I'm just going to see the contents of the envelope as black and white text on the screen, specifically only the first few lines, the so-called headers that the server is responding with, just as I claimed Brian would to Phyllis. I hit enter. And there's indeed more lines than I had in my slide, but you can see that everything is, in fact, 200 OK. This is a convention. 200 means all is indeed OK. There's a bunch of other information here, including the date and time in which this response came back. Here's that content type line, text HTML, and then some other details, and a whole bunch of other information as well. So that's one way of seeing what's going on underneath the hood. Well, what other responses might come back? Well, it turns out that 200 OK is the best possible outcome, but there's a bunch of other outcomes that are possible as well. For instance, sometimes you'll get not 200, but 301, which means moved permanently, colloquially speaking. And what does this mean? Well, if a server responds to a browser with a numeric code of 301, that means that the browser is supposed to go to this location instead. It's sort of like putting a detour sign on the server that says, there's nothing for you here, go over here to this location instead. And now notice in this example, it's telling the user to go to https://www.harvard.edu/. That's actually what I typed before, so I would not have seen that myself. But if I go back to VS Code here, and let's run the exact same command, but let's try to visit the insecure version of Harvard's website, http://, which just means that anyone else on the internet can technically see what it is I am now doing with my browser, which might not be desirable. Enter. This time, Harvard server does not just tell me 200. OK, it actually says 301 moved permanently. And if I read lower in these lines, there indeed is the location to which I should actually go. And it's a subtle difference. It's forcing me to go to HTTPS instead without actually showing me the contents of Harvard's website. So nowadays, you and I don't even have to think about this. You and I are not even in the habit, surely, of typing http:// or https://. But the browser is ensuring in this case that you are redirected, so to speak, automatically to the secure version of that site instead. Now, there's other status codes. And in fact, even if you never realized it before now, what numeric code do you sometimes see on the internet when something goes wrong? 404. So 404 is a weirdly public, arcane error number or status code that just means file not found. And we can simulate this as follows. For instance, if I, in my terminal window, do curl-I https://www.harvard.edu, I'll suppose that Harvard has a whole department dedicated to cats, which it does not. But if I hit enter here, you'll see that I get an HTTP 404 status code, which just means the website does not, in fact, exist. And if I visited https://www.harvard.edu/cats in my browser, I would presumably see some error page that may or may not show me visually 404. But many websites, most websites, for better or for worse, reveal this number, so much so that most everyone in this room is probably familiar with 404, even though its origin is this very low-level arcane status code buried in the HTTP headers inside of envelopes like these. There's a whole bunch of others if you'd like some fun facts. 200 is indeed OK. 301 is moved permanently. There's a bunch of other 300 ones that all relate to go elsewhere. 400 generally means that you as the user have somehow done something wrong, or next week, as we start writing code that talks to web servers, maybe your code has done something wrong when requesting a website. 500s are really bad. It means the server is messed up somehow. Either it's not available or the programmer made some bug in their code such that it's crashing with, for instance, something like an internal server error. We included 418, which is not actually a thing, but it was a fun sort of April Fool's joke years ago where a bunch of humans thought it would be funny to write up a whole specification for what it means for a server to respond with a number of 418. Inside joke. Not funny at the moment, but it is sort of part of internet lore nowadays. We can have a little bit of fun with this, maybe at the expense of our dear friends down the road. For years now, someone has been paying for the following behavior. Let me go back to VS Code here in my terminal window. Let me do curl-I http://safetyschool.org. Have you ever been? Ever apply, perhaps? Well, let me actually go to http:// safetyschool.org. And just for fun, hit enter. Oh my goodness, look at where we are. So how is this implemented? Well, if I finish what I began over here by just looking at the HTTP headers inside of the envelope my actual browser just sent to safetyschool.org, for like 20 years, presumably some Harvard alum has been paying the bill to rent this domain name just to have this trick implemented such that 301 Move Permanently is directing people ever since to yale.edu. There's a bunch of others if you go down the rabbit hole of looking on Reddit and the like, Stanford, Berkeley. There's a healthy competition on East Coast and West Coast. But it all boils down to very arcane understanding of how HTTP works, the protocol that governs how data is sent from web browsers to web servers. Now, you can, of course, use curl for connecting to URLs in the context of something like CS50.dev. You could have been doing stuff like this all the time, though, with your actual browser. So I'm using Chrome here. But most any browser nowadays has the ability to give you developer tools natively, which is to say somewhere there should be a menu option that lets you use developer tools that are conducive to someone who knows a bit of programming to poking around underneath the hood of the browser and see what's going on. For instance, I'm going to go ahead and open up a new window here. And I'm going to right click on the background, or I can go to the appropriate menu in Chrome's ... menu. And I'm going to go to Inspect, which pulls up what we're going to call developer tools. I'm doing it in incognito mode for reasons we'll see next week. This has the effect of clearing automatically any of my cookies, my browser history, because most anytime I do something with the web browser today, I want to pretend like I'm doing it for the very first time so that the behavior is exactly as we expect. So down here, now that I've opened up the so-called developer tools in Chrome, and they look almost the same in Safari and Edge and a bunch of other browsers as well, I will see a tab called Elements, which shows me all of the elements of this web page once it appears, including the so-called HTML code we're about to write. I can see a console where error message might sometimes appear, similar in spirit to the terminal window in VS Code. I can also see the network connections that the browser is making to the server. And that's where I thought we'd start our attention here. Here I have a brand new browser window. I'm clicking on Network over here. Just to make sure we can see everything without it getting automatically deleted, I've clicked on Preserve Log and Disable Cache, just so that it behaves exactly as expected. And now let's go up here for the first time in this incognito window and go to http://safetyschool.org, enter, and you'll see a whole bunch of output, including this warning in this particular mode. This is increasingly common nowadays for websites that do not support HTTPS, which this alum hasn't been paying for. You'll get a warning typically that specifies you might not want to do this because the whole world, at least the whole world between you and point B, might know what it is you're accessing on the web. I can go ahead and pass through this. In fact, once I do that and click on Connect to Site, we'll see even more output at the bottom and a whole bunch of output that's kind of overwhelming. Notice at bottom left here, just going to safetyschool.org resulted in 61 HTTP requests, in effect 61 envelopes going back and forth. I'm going to focus, though, on the ones at the very top here, whereby when we finally click through that warning and I got back a response from the server having visited safetyschool.org. Here is Chrome's presentation of the same information that curl was showing me in my terminal window. The message that came back was 301 Move Permanently. The protocol, or the verb being used was get. There's some mentions of the IP address in question here and a whole bunch of other stuff that we'll wave our hands at for today. So all of this time, you can see the same. And let's try this with some cats. Let me click on the little Ghostbuster symbols to clear everything down in the developer tools. Let me zoom out. And this time, let me go to https://www.harvard.edu/cats, which recall did not exist according to curl. If I hit enter, I do see a web page. It's interesting that Harvard has chosen to fairly arcanely reveal to all visitors 404, which means nothing except insofar as the status code. But if I scrolled through all of the 59 requests that were involved and just displaying this very graphical page and go back to the top, you'll see by clicking on the first row for cats itself that I used get to get it, that URL /cats in the end, and it was indeed 404 not found. So you can sort of have all this fun on your own by just poking underneath the hood of what your browser has been hiding from you all of this time. All right. Any questions now before we dive in? No? All right, well, that's the network tab. Let's look at some of the others and see how we can start writing this stuff ourselves. Let me go to stanford.edu, enter. A whole bunch of things will fly across the screen, but this time I'm going to go to the Elements tab. And what we're about to dive into is an actual language, not a programming language, a markup language called HTML, Hypertext Markup Language, whose purpose in life is just to tell browsers what to display on the screen. So here is all of the so-called HTML that some human or humans or software at Stanford wrote in order to create Stanford's homepage, which as of today looks lovely like this. The interesting thing, though, about the code that Stanford has written to generate this website is that it's being sent to me as a copy. And this is quite unlike the code we've been writing thus far. When you wrote code in Scratch, it was sort of there in the browser and stored on MIT's server. When you wrote C code and ran it, it was inside of the code space and not given to any user who might access it. The way the web works, though, is a little bit different. Inside of those envelopes are literally copies of what's on the server being sent to the browser. And so it's your browser, the so-called client, that's actually reading that code, HTML in this case, top to bottom, left to right, and figuring out how to display it. It's not executed on the server per se. Now that story is going to change a bit next week when we start using Python to dynamically generate HTML so that we're not writing all of this code by hand after this week. But for now, everything you see was the result of the browser executing code that Stanford wrote. The implication of that is that we can have a bit of fun with these same developer tools. For instance, if I control click or right click on something like the word Stanford in the middle of their home page, choose that same inspect option. What's nice about these developer tools is it's going to jump to the very line of code that created that Stanford brand name in the middle of the web page. And this is a wonderful teaching and learning tool because in the days to come, when you're trying to learn more and more HTML, you can literally do this for any website on the internet and understand how it is someone implemented a design, for instance, that you really like. And you can learn from other websites how they've constructed the same. So over here, you'll see that the word Stanford is just in the source code of this page, in the so-called HTML. And just for fun, I can change it to Harvard, hit enter, and now Stanford's website looks like we've been there, and rather hacked it. Of course, it's not that easy to hack Stanford's website. What have I presumably only done just now? I've changed my local copy of that particular website. So if I just click on the reload icon, I'll actually see that Stanford's website, for better or for worse, still looks like that. But this speaks to now the control that we have within our browser to actually manipulate and learn from what it is that's going on underneath the hood. So let's dive into this language called HTML, Hypertext Markup Language. It's not a programming language, which means we're going to fly through it even quicker than usual because it really just contains some basic building blocks that do have some interesting intellectual design under them. But for the most part, it becomes an exercise ultimately in just like looking up other tags that exist, read the documentation, and figure out how you can use them to do other features in websites. So let's take a look at perhaps the simplest of web page and specifically glean from them what tags are and what attributes are. Really the only two terms of art that are going to be germane for this particular language. No loops, no conditionals, no variables, no complexity really, other than basic building blocks like these. So here is HTML for the simplest of websites. This is like a mini version of what Stanford's team presumably wrote on their server, but it's only like a dozen lines of code instead of hundreds or thousands, however long that website was. Any web page written today, assuming it's using the latest version of HTML, which happens to be version 5 as of today, begins with code that looks like this. This kind of code will presumably be stored in a file called file.html, index.html, stanford.html, whatever the file is actually named. This is simply what's going to be inside of the contents. You could save this file on your own Mac, open it up, and your browser would open it, but you're going to be the only one in the world that can actually see the contents of that web page if it's just on your Mac or just on your PC. So we, of course, are going to be writing HTML on a server so that not just you, but in theory, especially for your final project, anyone on the world with an internet connection can access the same. So we, within the context of CS50.dev, are going to start using this new command, HTTP server, whose purpose in life is just to serve up files via HTTP. Now, there's kind of an interesting design going on here, because if we use CS50.dev, otherwise known as GitHub code spaces, there's already a web server running on that website. Because when you go to CS50.dev and log in and get redirected some longer URL, you're using a web application application, aka VS Code, that allows you to write code in the cloud. Now, that application, by default, is running on port 80 and 443. So it doesn't matter if you start at HTTP or HTTPS. Both will work. But that means that your code that we write today and you write for the next problem set or for your final project can't live at port 80 or port 443 because GitHub, the company that hosts this, is already using those default standard ports. But we can use any number of other port numbers. I claimed earlier there's tens of thousands of numbers that we could use. So that's what we're actually going to do. So let me go back to VS Code here. Let me shrink down my terminal window. Let me create a first file today called, for instance, hello.html. Enter. And now I've got an empty tab as usual. I'm going to very quickly whip up the exact same contents that we just saw. So an angled bracket, an exclamation point, doc type HTML, then open bracket HTML, close bracket. And notice the autocomplete kicked in for this particular language, so I don't have to type everything myself. Inside of this tag, so to speak, I'm now going to put a head tag, inside of which is going to be a title tag. I'm going to say something like hello title, just to be quick. And then down here, below those lines, I'm going to put a so-called body tag, inside of which is hello body, just for some quick text. And that's it. This is now a file inside of my code space. And there's no command to just compile or run this in the terminal, because the goal is going to be to open this HTML file with a browser. If I want to do that in another browser tab, I need to tell my code space to serve that file via HTTP. So the simplest way to do this is as follows: HTTP-server, enter. You're going to see a whole bunch of text on the screen. You're going to see a green button hopefully pop up that says Open in Browser, which is going to allow you to open up, and I'll zoom in, the contents of the current folder with a web browser. My URL has changed to be different from what it was a moment ago. I came in advance today with my own folder of code like we usually do, source8, which contains all of today's pre-made examples. But here is the file I just created a moment ago. And if I click on that, hello.html, what we're looking at the moment is just a directory listing, a directory index of all of the files in my code space right now. I see the simplest of web pages. It's a little underwhelming, but clearly here's hello body, which takes up like 95% of the screen, the so-called viewport, which is just the big rectangular region of the screen. But there's the title in the tab up there. So if you've ever wondered or cared, like, where does the content in a web page come from? Well, here's the body content. Here's the head or the title content. And then everything else is just sort of icing on the cake. So I've written, at this point, a file called hello.html. It has yielded this effect of having something in the head, the head of the page and the body. But let's actually tease apart what just happened. So at the start of any file written in this language called HTML, the latest version thereof, 5, it literally just starts with this. And this is just the kind of thing you memorize or copy paste. Open bracket, exclamation point, doc type HTML, close bracket over there. It looks a little bit different because we're not going to use, for the most part, the exclamation point syntax anywhere else unless we're using an HTML comment. So HTML has comments just like Python, C, and other languages. But let's focus really on this juicier part. Here we have what's known as an element in HTML. An element includes a start tag and an end tag, or equivalently an open tag and a close tag. So here, for instance, is syntax that essentially is going to tell the browser, when my browser reads this file, top to bottom, left to right, hey, browser, here comes the HTML of my page, and the language in which the contents of this page are written are in English. So HTML, all lowercase, is the name of the tag, so to speak, and equivalently the name of the element. Lang is what's going to be called an attribute, which just modifies the default behavior of the element. And quote unquote en is the value thereof, which is the shorthand notation for English. And there's shorthand notations for most every human language as well. So you have a tag name and an attribute with a value. And we've seen these things so many times, these key value pairs in the context of dictionaries or hash tables or any number of other contexts. Key value pairs in HTML are separated by an equal sign, with the value typically quoted in this way. Double quotes or single quotes, but being consistent. Then notice, at the end of this file, as per the indentation, there's something symmetrically down here that has the effect of closing the tag or ending the tag. And this effectively tells the browser, hey, browser, that's it for my HTML. Meanwhile, everything else follows the similar paradigm inside of those two tags. Here is a head tag that says, hey, browser, here comes the head of my page. Hey, browser, that's it for the head of the page. Hey, browser, inside of the head, here comes the title. That's it for the title. Well, what is the title? Hello, comma, title, just as I wrote in my code space. Same story for body. Hey, browser, here comes the body of the page, the 95% of the screen. That's it for the body. But what's in the body is exactly that. The indentation is nice and pretty printed. I've used 4 spaces, as we commonly do. Not strictly necessary. In fact, in my own code space, I didn't even bother putting these on 3 separate lines. I just did 1 line. That's fine, because as we'll see, browsers typically ignore white space. But I've done it there, as we often do, just to ensure that things are pretty printed and therefore readable by us humans. Let me call your attention to one other thing on the screen. Up until now, before every lecture, I've been hiding a whole bunch of tabs in my terminal window. But today, I left enabled one that you've probably seen but not cared about before, namely ports. And it's under this ports tab that you can actually see a real incarnation of a TCP port. By default, when you run the command HTTP server, it serves up my current folder's contents on its own web server, its own HTTP server, but not using the default port 80 or 443, because GitHub is already using those on CS50.dev and their product. But by default, we've chosen another common developer port number, 8080, which is interesting only insofar as it's 80 twice. But it's a human convention. But it could have been any number of thousands of other possibilities. But this line here is just telling me that I am apparently running a server on port 8080. And if I click on there too, I can manually open the same tab. But that's what the green button was doing for me. It was informing me, hey, you've just started a web server on this port. Do you want to open a new tab with the contents thereof? So this is the picture we're now painting. Let me pull back up the code that we just wrote. And let me propose that what we've really done is built a tree in the browser's memory. So we kind of have come full circle with week 5 when we talked about trees and other hierarchical structures. If we assume that the document can be represented with a node that looks a bit like an oval up here, that just represents the whole contents of the file. Well, it starts with a single root element by convention, the HTML element. And your page can have only one of those elements. But the HTML tag inside of it can be a head tag and a body tag. And in this case, the head tag, recall, had a title tag, as well as the actual text thereof, which was hello title. Meanwhile, the body had just the text thereof as well. And so when I keep saying that the browser is downloading the file, for instance, hello.html, reading it top to bottom, left to right, it's doing literally that. But somehow or other, it's using malloc or whatever language it's written in to allocate node, 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 and populating that tree in your browser's memory or RAM, a data structure quite like that. So it's all sort of germane to where we've been before. Before now, we take, I think, a snack. Are there any questions about what we've just seen? Anything at all? Shouldn't have prefaced this with the only thing between us is these questions and snacks. No? All right, snack time. All right, see you in 10. Snacks. All right. So we are back, and pretty much everything we do here on out will look structurally like this. And we're just going to introduce a few more tags and a few more attributes to give you a sense of some of the basic building blocks of most any website out there. And you'll find pretty quickly that it starts to get kind of tedious writing it out. In fact, I will resort to some copy paste today just to kind of speed things up. But this is going to motivate, indeed, next week when we reintroduce Python as well as SQL to actually automate generation of HTML as well. So all of today's websites and many of today's mobile apps are written in HTML, but people are decreasingly writing this kind of stuff by hand. Rather, they are writing code that generates precisely what we're going to learn. So understanding the fundamentals will still be useful so we know what code to write next week and beyond. So let me go back into VS Code here. And what I'm going to go ahead and do is open up another terminal window so that I can leave HTTP server running in this first terminal window. And what I'm going to go ahead and propose that we do is implement a web page that has not just a single line of text, but maybe some paragraphs. So I'm going to call this paragraphs.html. That's going to open up a new tab. And here's where I'm going to save some time. I'm going to go back to hello.html and just highlight all and copy paste this as the beginning of this file. But what I'll start doing is just changing the title of each page to match the file name. So this is going to be my paragraphs example. And instead of saying just hello body, let's actually have a few paragraphs of text. I'd rather not waste time writing even full paragraphs of text. So let's actually open up the doc and let's log in and, for instance, just ask it for a quick helping hand here. Write 3 paragraphs about computer science. Don't really care what the output is. All I want is some dynamically generated text to save me some keystrokes. And here we have an educational answer there too, even though all we really care about today is the fact that this is 3 chunks of text. Hopefully that's all quite accurate. All right, I'm going to go ahead and highlight all of that, go back into my paragraphs.html tab, paste it inside of the body. It's so long, the paragraphs, that the text scrolls. I can at least clean this up slightly. I'm going to go ahead and just indent it twice just so that at least it's pretty printed inside of the body. And now I'm going to go back to my other tab, which represents the contents of hello.html. I'm going to click back, which is going to show me that same directory listing again, which now has a new file, paragraphs.html. And I'm going to click it so as to see these 3 paragraphs of text. What looks wrong? Yeah. And there's no paragraphs. It's just one big blob of text. It's the same text, but buried in there is the end of the first paragraph and the start of the next, and same for the third. So what's going on? Well, apropos of my comment earlier about browsers not really caring about white space, you can put all the white space you want there. It's just going to ignore it in this particular case. All it's going to give me minimally is a single space between each of these paragraphs of text. So HTML is very pedantic. Like if you want there to be more paragraphs, you need to tell the browser, put a paragraph here, put a paragraph there. And the way to do this, thankfully, isn't all that hard. I'm going to go inside of the body here, and I'm going to simply open a tag called P for paragraph for short. Notice that VS Code in this particular case is a little annoying because it's trying to finish my thought, but it doesn't know that I already wrote this text. So I'm just going to delete what it automatically generated, and then I'm going to manually indent this. And I'm going to do the same thing again for the other paragraphs. Up here, I'm going to open the paragraph tag. I'm going to delete temporarily the close tag so that I can actually put it below that chunk of text here, indent this, and then down here, and this would have been easier if I just did it right the first time, I'm going to do the same thing with the third and final paragraph. So now what we in effect have 3 times in a row is, hey, browser, here comes a paragraph. Then the first paragraph. Hey, browser, that's it for the paragraph. Hey, browser, here comes a paragraph. That's it for the paragraph. Hey, browser, comes a paragraph. So 3 times in total with open, close, open, close, open, close. Now, if I go back to the browser, nothing appears to have changed yet, but that's because I'm looking at a copy that was downloaded a moment ago in that virtual envelope. So this is why, among other reasons, we hit reload on web pages to get the latest version. And voila, now we have 3 actual paragraphs. The white space is inserted automatically by the browser, but it's at least prettier to the eye now. So that then is the paragraph tag. So useful, of course, if we have paragraphs of text, what are some other tags we might introduce? Well, maybe you're writing a paper or a blog post or the like. It's pretty typical to want headings of sections of the page, maybe chapters and then sections and then subsections or the like. HTML can help with this too. So let me go into my terminal window again, create a file called, how about, let's call it headings.html. And then in this file, let me similarly go back to hello.html, copy paste it into headings. I'm going to close paragraphs because we're done with that. And I'm just going to change the title now to headings. And inside of the body here, what I'm going to go ahead and do is, you know, it would have been nice to have some of that same text. Let me go back one step. Let me grab the paragraphs and paste that into this new file. Let me rename it to headings to make clear which file we're in. And now let me go ahead and propose that wouldn't it be nice if I made clear that this is the first paragraph? So I'm going to use the h1 tag, which is the heading 1 tag. And I'm just going to say 1 for the sake of discussion. Down here, I'm going to say h2 and say 2 for the sake of discussion. And down here, h3, 3, because I don't really care what these things are called, just want to demonstrate the functionality. If I go back to my other tab now, back to the directory listing, there's my brand new file, headings.html, and it's the same paragraphs. But now you have some big, bold text that looks reminiscent of the chapter heading, the section heading, the subsection heading, and the like, or that you might see on a news site or a blog site or the like. So you've got h1 through h6 from biggest and boldest to smaller but still bold. And the browser decides on all of those settings for us, but it also makes some semantic clarity to me that probably the most important thing on the page, at least to begin with, is that h1 tag. And then everything else is like supporting paragraphs or arguments or whatever the case might be. There's a hierarchy implicit there. All right, what are some other things we can do with web pages? Well, let me open my terminal window again. And why don't we code up, how about a list of values? Because lists are everywhere on the internet. So let me open up list.html and then close my terminal. I'll go ahead and start with that same file, headings.html, paste it into list, change the name here. Let's delete everything I did. And again, the only reason I'm copying and pasting is just to avoid writing out the same boilerplate code again and again with the HTML tag, head tag, body tag, and so forth. Let's focus on the new stuff. The new stuff in this example will be a list of values, like the words foo, bar, and baz, which, much like a mathematician, might go with x, y, z as placeholders. Computer scientists would typically reach for words like foo, bar, and baz when nonsensical placeholders. And this looks like a list of 3 values, one after the other. Of course, if I go back into my directory index, click on list, how many list items am I going to see per line? Yeah, well, it's going to be just one big blob of text here, too. It doesn't matter if it looks like a list. It is just going to be text after text after text separated by a single space, not the multiple lines I had. So here, too, we've got to be pretty pedantic. If I want a list of values, I need to use a tag that conveys that. And the tag I'll use first is going to be UL for unordered list, which gives me a bulleted list. And then inside of this unordered list, I claim we can have a whole bunch of list items, or LI for short, like foo, like bar, like baz, or any other things that you want to put in your list. If I now go back to my other tab, reload, now you get the familiar bulleted lists that you might see in any number of websites, Google Docs, or the like. How does Google Docs do it underneath the hood? Well, they're just using a UL tag and some LI tags inside of that to give you the bulleted list that's just happening automatically when you click the appropriate button in something like Google Docs, which at the end of the day is just a website. Well, what if I want to number these things? Well, if I go back to VS Code, I could certainly just start numbering them like 1, 2, 3, which is fine, but honestly, like, computers can count and with loops pretty quickly. Also, it's a little annoying if I want to go back in later and insert something between some of those elements. I then have to renumber everything manually. I mean, this is one of the things computers are good at. So take a guess. If I want not an unordered list, but an ordered list that is numbered, what might you change? Yes, OL is a good bet. Let's change both the open tag and the close tag. Let me go back to this, my second tab, reload, and now we have it. 1, 2, and 3. And you can actually use a whole table of contents. You can use sub-bullets or sub-numbering. Anything you can do in like a table of contents, HTML can do for you automatically here. Well, what about tabular data, laying out data in kind of rows and columns? Well, we can do that too. Let me go ahead and open up a new file. How about table.html? Let me go ahead then in this file, copy paste as before, just so I have some boilerplate. Let's get rid of everything in the body. And then let's just manually whip up a little table like this. Open bracket table. Inside of the table tags, I'm going to have a tr tag for table row. Inside of this table row, I'm going to have a table data tag, which is going to have the number 1. I'm going to give myself another 2, another 3. Outside of the table row, I'm going to have another table row, and I'm going to create maybe 4, and now I'm going to do 5, and now I'm going to do 6. And you can perhaps see where this is going. After this, I'm going to do one more table row. How about, a little tediously, 7? How about 8? How about 9? And then lastly, just to make it look a little familiar, final table row, how about with a TD of an asterisk? And then how about a 0? And lastly, how about a pound symbol? Maybe any guesses as to what we're making in HTML here? Like a telephone keypad? Yeah, so let's go back over to, let me close the old file, back over to the browser, click back. There's my new file, table.html, and it's not going to be very pretty, but I dare say that's exactly what you see when you pull up the phone app and you start dialing a number. It's sort of a numeric keypad laid out automatically for me in rows and columns. Now, this one's a little underwhelming. Let me open up a file that I made in advance of class today in my favorites file here. I'm going to go ahead and copy a pre-made example. I'm going to open up this file called favorites0.html. And what you'll see here is a slightly more complicated table, still with a table tag, but this time with a t-head tag for table head, and then a t-body tag, inside of which are all of those rows. And I know this just by having read the documentation. And then notice this, inside of the first tr in the t-head, there are 3 ths, table headings, timestamp, language, and problem, which might sound a little familiar when we last collected data from everyone via that Google form. Well, let's go ahead and spoil what this is. Let me go back to the directory index. There is this pre-made file, favorites.html, and arguably a more compelling use of a table. now we have an HTML table containing all of the form submissions that you all clicked in with the other day when we were asking you your favorite language and your favorite problem. It's not super pretty, but indeed it's in rows and columns. And so it's reminiscent of the HTML that Google is using in the actual Google Sheets software to lay out a sheet of data for you in those same rows and columns. All right, well, let's do something that's a little more visually interesting. Let me go back to VS Code here. Close out those last two. And how about let's do something with images? Well, I brought, again, inside of today's code, how about our same bridge that we keep opening up in class? And this is the week's bridge. Looks a little something, looks a little something like this. Here, though, is just the raw image. How could I include an image in a web page that I serve up on the internet? Well, let's go ahead and try this. Let me close the ping itself. Let me copy this and create a new file called, how about, image.html. Hide my terminal, copy paste that. Just quickly change the title to image so we know where we are. And inside of the body of this page, let's go and embed that image so that we can include not just the image, but if we want, paragraphs of text around it, headings as well, heck, maybe a table, any other features that we've seen already. I'm going to say img, which is image for short, source, src for short, equals quote unquote bridge.png. And then I'm going to close the tag here. Now I'm going to go back to my other tab. Go back into my directory index. Here's my brand new file, image.html. And this too isn't going to look all that different from the actual image because I have no other content. But when I click on this, you'll see that there is the full screen image. And it's even a little too big to fit in my viewport in the body of the page. But we can fix something like that later. I've embedded in this website precisely that image. But I should do a little bit better here. In fact, if the image is slow to load, or if someone is visually impaired and doesn't know what they're looking at, it would be nice to have some alternative text that something like screen reader software could recite. So there's another attribute for this tag specifically called alt for alternative. And I can put something like Harvard University to at least give the user a textual description of what kind of photo they're looking at. You'll also see that text if indeed the image is slow to load, or if it's broken, like missing altogether. You won't see 404. You'll see like a broken image icon, but at least with some explanatory text as to what the developer intended you to see at that point. It's not going to change at all if I reload here by going back to image.html. But again, a screen reader or an astute viewer would see that ultimately in the browser. But there's something different, and this isn't a mistake for once. What have I done differently, but apparently not wrong, I claim? Something new or noteworthy about this particular image tag. Yeah. Yeah, there's no like close tag. There's no like open bracket /img, which is the pattern we followed for every other tag, like closing the HTML tag, the head tag, the body tag, and so forth. I just don't see any end tag here, and it's just not necessary. Turns out there are certain HTML tags that can be empty elements, which is to say, it doesn't make semantic sense to start and end an image. Like it's either there or it's not. And so some tags just don't require an end tag if it's sort of obvious to the browser that the image should go there. So image is one such of those tags. And then I noticed I'm missing the lang here, which isn't strictly necessary because I've got no textual content. But just for consistency, let me go back and put that in as before. Meanwhile, the image is exactly as it would appear in the screen. But it doesn't have to be just an image we embed. We can do something with like video. So let me go ahead and open up a file called video.html. Let me copy paste some of that starter code, change this to video. And instead of the image tag, as you might imagine, there's also a video tag. It's a little more involved, but per the documentation, I know I can do this. Video. And then inside of the video tag, I can actually have multiple sources just in case the browser might want different versions or different resolutions, sort of qualities thereof. And this, somewhat confusingly, is an actual tag called source, not shortened. But stupidly, this tag has an attribute called source, which is shortened. That equals the name of the file you want to embed. And I came with today's examples, a video file called video.mp4, which is a small video that you can embed. And I can tell the browser what type of video it is, to be clear. And the convention here, or content type, is to say the type of this video is an MPEG-4 video. There are other features, though, for the video tag. In fact, when you see a video on a page, you can very often see like a play icon, a pause icon, maybe some other controls. Well, it turns out you can put an HTML attribute on the video tag, literally called controls, that will enable those. If you don't turn them on, there's no way to like start and stop the video or see rather those controls visually. This way, the user actually sees them. But this attribute is a little bit different from others. It doesn't actually need a value. It just has to be present, and the browser will know when it sees the word controls, oh, I should turn on the controls feature. And for good measure, especially in today's world of advertisements everywhere, if you want the video to play automatically, potentially, or at least not annoy the user, you might want to mute it by default as well. So another attribute per the documentation for the video tag is that you can start the video muted as well. And only when the user clicks on it might you actually start to hear something. But of course, these are fairly basic examples of media inside of pages. Let's actually do what the H is meant to imply in HTML, the hypertext, the ability to link from one page to another. That is a feature we haven't yet seen. So let me go ahead and do this. And let me, just for completeness, let me go back into hello.html because I completely forgot the language attribute, even though that's really just there for SEO, search engine optimization, or for tools like Google Translate or the like that know, therefore, what language they're translating from. Let me go into my terminal window here. And let's create another file called link.html, which demonstrates exactly that, the ability to link from one web page to another. Let's go ahead here and change the title to link so I know where I am. And in the body of this page, let's go ahead and create what's called a hyperreference or hyperlink. I'll encourage people in this page to visit the actual Harvard website. So let's do visit. How about Harvard period, just to demonstrate where we're beginning. If I go back into this directory index, click on link.html, this, of course, is not yet a link, so I should probably make it one. Well, instead of just saying visit Harvard, maybe I should say harvard.edu. Go back to the other tab, reload, and it's harvard.edu, but I can click and highlight it, but it's not clickable. It's not underlined like a link. All right, well, maybe I need to do like www.harvard.edu, reload, still nothing happening. All right, well, maybe I need the full URL in the scheme, https:// and maybe the slash at the end. Reload again, and nothing's happening. So here, too, HTML is pedantic. Like, it will not create a link for you unless you tell it to create a link. And the fact that when you post on social media nowadays or in Google Docs, things are automatically hyperlinked for you, like that's a feature implemented in code. Very often Python or JavaScript or something else where some human wrote code that looks for patterns in the input you've typed in. And if it looks like you've typed a URL, it will automatically link it for you. But what are those websites doing for you automatically? Well, they're doing this. If you want to have a tag, a link here to Harvard's website, you use open bracket A for anchor, href for hyperreference, set that equal to the URL to which you want to link, close the tag, and then in between the open tag and the close tag, put the actual word you want to link to. So now if I go back to this page and reload, now I have what looked like my original attempt, just visit Harvard, but it's a hyperlink. And this is super subtle, but if I hover over that underlined word, which is blue by default, you'll actually see in the browser's bottom left-hand corner where you're going to be whisked away to, even though that's all too subtle. But this now looks like I intended, an actual hyperlink to Harvard. In fact, I could link it to the full URL, but it would be a little redundant. And even though this looks like you shouldn't have to do this, this is indeed how HTML works. The href attribute is where you're going to go. The text inside of the open and close tag is what the user will see. So if you want them to see the full URL, you got to put it there. And now I can see the full URL to where I'm being led. But here's where you can actually introduce discussions of like cybersecurity. How could this feature be abused, might you think? This stupid, simple feature. Yeah. Yeah, you could have it display one thing but lead to somewhere else. And it wouldn't be that hard for the adversary who's maybe tricked you into visiting their web page to say, oh, you're actually going to go to yale.edu instead of Harvard. But if I reload the page, it doesn't look any different unless the viewer is astute enough to look at this tiny little text in the bottom of the screen or just click on the link and be whisked away to the wrong destination. That can be problematic. Like, this is a nice haha sort of prank. But you could certainly imagine doing this with like PayPal.com addresses or any number of banks or anything where you're trying to collect personal information from someone. And if the resulting website looks quite like the one you're actually creating, it looks quite like the website they're expecting, but is actually your copy thereof, it's all too easy to wage what are called phishing attacks, P-H-I-S-H-I-N-G, which means to lead someone to what looks like the real site, but is not, typically to get their username, their password, their credit card information, or something else. But it boils down to just these basic building blocks like this. Questions then on any of these building blocks that we've seen thus far? Yeah?
I think I might have gone lost in the earlier portion.
Sure.
But how did you get it to open up? Did you run the file in VS Code?
Oh, good question. How did I get it to open up? So let me rewind. So the very first thing we did after creating hello.html was open a terminal window. And specifically, I ran a command which was http server. HTTP-server, which starts my own web server in my code space, but not on the default port, 80 and 443, because that's what CS50.dev is already using. Instead, it chose by art design 8080, which is commonly used by developers when making websites. Then I just kind of hid my terminal because it's not interesting to see constantly then. But that web server is still running in my code space. And anytime I'm saying, let's go back to this tab, I am now visiting a different URL that was the result of my clicking on that green button, which led me to my own website. If you ever get lost or close that tab by accident, no big deal. If you go to the ports tab of your terminal, you can actually hover over this and click on that same URL and open up the contents of your own site instead. Fluffy meme? Yes, these are randomly generated names by GitHub, which is the company that hosts VS Code in this way. And they do this to ensure uniqueness without it being some arcane sequence of random letters and numbers. They concatenate random English words together. A good question. All right, so what else can we do here? Well, let me propose that there's a bit more you can do with even these URLs. Here, of course, is the scheme and the host name and the domain and the TLD. But after the URL, things can get a little more interesting than just folder names and file names. In fact, it's quite common to see URLs that have somewhere in them a question mark and then a bunch of other key value pairs, which is this omnipresent computer science thing, it seems, including in the context of URLs, whereby if you want to pass a input to a web server, one means by which you can do that is literally in the URL itself. So for instance, if you visit google.com and you want to search for something, you and I are all in the habit, of course, of just typing into a search box. But how is that search box actually getting the data into Google's servers? Well, it's via these URLs. And if there's not one input but two inputs, the URL might be a bit longer, and there might be one or more ampersands in the URL that just separate more key value pairs. And it turns out we can see this in the real world as follows. Let me go back to VS Code here. Let me open up a new tab. And let me open up google.com. And I'm just going to hit enter on the shortest way of saying it. So I get to Google's homepage here, even though notice I ended up at some longer form of the URL. In fact, I'm going to delete everything else from the URL that's not relevant to us today. It's still forcibly coming back. So Google is somehow trying to track me by putting that in there. That's fine. All I'm going to do is search for cats. Now, there's a whole bunch of other functionality that's clearly happening, like autocomplete, and it's trying to figure out what results or words I might want. I'm just going to go ahead and hit enter. And this is all to say that notice if I zoom in on the URL at the top of my screen, it's a crazy long URL because Google probably is doing a bunch of tracking and advertising and analytics, technologically none of which is relevant to us today. But notice after www.google.com, there's /search, which is the path on their server, the search program that someone there has written. There's a question mark. And then there is an HTTP parameter, as these things are called. The more precise name for key value pairs in URLs, this is an HTTP parameter. Its value after the equal sign is, in fact, cats. All this other stuff, I have no idea what it is. I'm going to just delete it and hit enter. And it stays gone, but I still get cats in my search results. So this, I would argue, is sort of the canonically shortest form of a Google URL that's useful. In fact, if I want to search for dogs instead, I don't have to use the search box. I can literally manually make my own URL, hit enter, and if I zoom out, there are Google's search results about dogs. So this URL too is sort of the essence then of how URLs work, and specifically the get verb, which was that keyword in all caps that I claimed was inside of the envelope, and it's what Phyllis's browser was sending, and it's what my browser has been sending through all of these examples. But here's where things now can get interesting. If I know how Google's server works, its back end, the part that knows all about cats and dogs on the internet, I can implement my own front end by just knowing a bit of HTML. So let me actually go back into VS Code here. Let me go into my second terminal, which is blank. And let me go ahead and create something called search.html. I'm going to go ahead and copy my original code, close link, and paste it here, hide my terminal, call this thing search. And then inside of the body of this page, I'm going to make my own version of Google here. I'm going to use a form tag. And I'm going to, in that form, specify an input tag whose name is going to be exactly equal to what I saw Google uses, Q, which happens to stand for query. I am then going to add another one, input. The type of this button, actually, let's say the type of this box, this input is going to be text. The type of this next one is going to be a submit button. And then that's it. Let me go back into my other tab, go back into my directory listing, click on search.html. And this is not pretty, but it is the beginning of my very own search engine. Unfortunately, if I type in cats, notice what happens. My URL changes such that it's search.html !Q equals cats. I know nothing about cats. I don't have a database of cats. I haven't done any back end work, just the front end. The front end is what the user sees. The back end is what provides data to the front end. But why don't I tell this form not to submit to me, but let's say that its action should actually be go to https://www.google.com/search, which is the URL that I saw in my browser. I'm just inferring how Google works. I'm going to be pedantic, even though this is the default. I'm going to say the method I want my form to use is get. Confusingly, it should be lowercase here, even though inside of the envelope it will be all caps. And then I'm going to go back to this page, reload after going back, and you'll see the same exact box. But when I search now for cats, submit, notice my URL changes to Google's own. So like voila, like I just implemented my own Google without doing the actual hard part. I've actually just done the more simple front end. And there's a few other things I can do here that are sort of nice. I can change the type to be a search box. I can change the value of my button not to be the default, which notice was submit. I can say Google search. And I can keep tweaking this to make it even prettier and prettier. Here now, in my version, is now a box that has cats. Notice that it's trying to complete my thought. I can actually go back into the form. I can say autocomplete equals off to turn off that feature. So now if I click in this box and type, autocomplete equals off. Why is it still there? Did I forget to refresh? Oh, thank you. I forgot to refresh, hence my point. So you always have to reload after making a change. And now the autocomplete feature is off. And this other little thing, it's subtle, but this little X that will just clear the whole thing, that is simply the result of having changed text to search for the type of that box. There's other things you can do, too, for accessibility or user friendliness. I can do auto focus here, for instance, without any attribute or without any value. If I now reload this page, notice that the cursor is automatically blinking in the text box, which is a marginal change, but much easier for me to now type cats without having to stupidly click in the box in order to actually foreground it so I can type input. So suffice it to say, this is not really the business that Google is in. They do much more on the back end than they do on the front end. But with just these basic building blocks, can I implement the beginnings of the same website? In fact, let me do one other flourish. You'll see that the text box is blank, not clear what I might want to do. Well, there's another attribute I can use, placeholder equals something like query. I can at least tell the user what to search for. If I reload again, now I see in gray text query instructions so that I roughly know what now to type. So all of these things that you see every day on websites are really as easy as just coding up some HTML like that. But what else can we do with HTML? Well, it turns out, this is a topic for another longer day too, there exist in computing what are called regular expressions, which is a fancy way of describing patterns, which are quite useful when you want to validate input. For instance, if you want the user to have to type in an email address with the @, with the TLD, and so forth, it would be nice to make sure that they get a warning if they try to skip that field or they mistype something in it as well. With the world of regular expressions, known in short as regexes, you have a whole bunch of documentation here that in a nutshell we'll introduce you to some pretty powerful syntax that we won't spend much time on at all today, but it's syntax that exists not only in the world of the web, but in Python and so many other languages as well. So consider this just a quick crash course. If you want to define a pattern in, say, a website that ensures that the user types in an email address, you can use these textual building blocks, whereby in the world of regular expressions, a single dot represents any character. If you don't care what the character is, dot, confusingly, doesn't represent a period. It represents any character. Star represents 0 or more times. Plus means 1 or more times. Question mark means 0 or 1 time, if you want something to be there or not. Curly braces with a number means this many times n, and you can even have a range of values instead. And then you can use square brackets and some other syntax to say, I want the user to type in any of these characters or digits in this case. Or you can do ranges like this. I want them to type in any decimal digit between 0 and 9. Or \d represents any digit. \D means anything that's not a digit. Long story short, humans over the years have come up with shorthand notation known as regular expressions via which you can define patterns. This is useful because if I wanted to make a web page that does in fact require that someone type in, say, an email address, I can enforce that to some extent. If I go back to my browser here and into VS Code, let me go ahead and create a new file called, say, register.html to be representative of registering for some website. I'll change the title here real quick. I'm going to keep the form, but in this case, I'm not going to bother with Google anymore. So let's make it a bit simpler than before. And let's go ahead and do this inside of the form. I'm going to have an input. I'm going to have the name of this input be email, because that's what I'm collecting. I'm going to have a placeholder be quote unquote email, so the user knows what to type in. And I'm going to go ahead here and have something like, how about this? A pattern as well. So actually, let's say type equals text. But I'm going to specify additionally a pattern. So the pattern I want the user to type in between these quotes is going to be any character 1 or more times. That is to say their username. Then an @, then any character 1 or more times. Then literally a period. And we didn't see this on the screen. But just like in C, when you want to escape special characters, if you want literally a period in their input, as like the dot in harvard.edu, you can say \period to mean a literal period, and then the word or the TLD edu. So I think now what this means, and let me go ahead and give myself a button, and just so you've seen it, there's also a button element in HTML, which is similar in spirit to the submit button we saw a moment ago. Let me go back to my directory listing, go into register.html, and let me go ahead and just type in like Malin as my name, register, and you'll see, please match the requested format. So I have not satisfied it properly until I actually type in something like Malin at harvard.edu, and now it's happy. Alternatively, it's a little tedious to actually type in these patterns, so there are some shorthands for them. I can actually get rid of this pattern, and if I read the documentation for HTML, there is actually an input of type email, which just does all of that pattern matching for you. But the scary thing is that it's actually pretty involved to validate email addresses. I did a very simplified version of username at domain.tld. This is the regular expression that some browsers use to validate email addresses, because even though mine is relatively simple, Malin at harvard.edu, turns out there's a crazy amount of syntax that is valid in email addresses. And this is where regular expressions get scary. But for our purposes today, they're a thing that exists. You might find them useful in HTML. You might find them useful in Python. They're incredibly useful when it comes to extracting information from web pages. If you're analytically minded, you like the world of data science, you like to gather and analyze data, you can use regular expressions not just to validate data, but to find patterns of data in actual websites or documents and extract that data so as to perform operations or analysis on them. So wonderfully useful, if complicated, tool. The catch, though, is this. Notice that here, I'm still required to type in a valid email address, register. And I'm getting even more explicit information this time because I use the type equals email. The catch, though, with web pages is that they're not to be trusted. Insofar as this HTML came from the server and is downloaded onto the user's Mac or PC or phone where they have a copy thereof, I can open up developer tools as I did before by right-clicking or control-clicking and choosing inspect or whatever the menu option might be. I can go into the elements of this page, literally the HTML. And if I don't want to type in email, I want to just type in any old text and see if I can break your site, I can just change it. And now there is no such warning, which is to say, even though you will encounter, not just today, but over the coming weeks as you play with HTML, certain features, they are not to be trusted in general when it comes to security. And just like our discussion in the world of SQL and SQL injection attacks, this is one of the attack vectors. If two people are working on a website, one person's implementing the database stuff, one person's implementing the HTML, and the database person's like, oh, I don't need to worry about escaping characters because we're using the pattern attribute in the HTML. Bad idea, because it's this easy to hack a website, disable features that have been written for the site by just literally deleting them in your own copy. So we'll see next week how we can defend against this on the server side. But the point now is just not to trust the user's input at all. All right. How can we be sure our HTML is right? Well, there's a bunch of ways, but one tool that's worth knowing about is this one here. At validator.w3.org is a website by the group that essentially standardizes this and other languages. If I click on their Validate by Direct Input tab, and I quickly go back into VS Code, and let me grab the simplest of my examples, hello.html. I can just copy paste that into their website, click check, and they have written code to validate that the HTML I have written is in fact correct. Anything I've opened that needs to be closed has been closed. I don't have any stupid typos or missing brackets or quote marks. This is a wonderfully useful tool just to validate that your code is syntactically correct. Even though it might still look like a mess visually on the screen, this will at least check for you the underlying HTML. All right, so up until now, everything I've done has been pretty boring. It's black and white. The pages are fairly simplistic. Turns out we can take things the final mile using another language altogether, namely something called CSS, which is the second of our 3 languages today. This too, not a programming language, although curiously, they keep adding more and more features that are making it more and more like a programming language, but more on that another time. This stands for Cascading Style Sheets. And whereas HTML is all about the skeleton of a website, the structure thereof, CSS is like the skin, the aesthetics thereof, the final mile that actually allows you to control the positioning of things more precisely, the colors, the font sizes, all of the aesthetics. It lets you do the finer touches on the website. And with CSS, we have slightly different syntax, but frankly, it just boils down to even more key value pairs. And as with HTML, we'll give you a taste of the basic structure and principles underlying CSS. There's so many key value pairs that are possible that we certainly won't do them justice today, but it's the kind of thing where you ultimately look it up in a reference, a book, a website, or the like to pick up even more than these techniques. Well, let's do this. Let me propose that in a moment, we're going to see what are called properties. This is CSS's jargon for key value pairs. Why do we have yet another word? It's because a different group of humans in a different room came up with this language versus the other people. But it's just key value pairs known as now as properties instead of as attributes in HTML itself. There's going to be different ways we can define properties. And this is kind of a laundry list of some of them. And we'll see them in context. But in short, CSS is just going to allow us to slap a whole bunch of key value pairs on our HTML elements to make them hopefully look prettier or be more precisely controlled aesthetically. So in my HTML thus far, we've generally had something that looks like this. Turns out, if I want to start using some CSS, I can introduce, as we'll see, a so-called style tag in the head of my page. And inside of that style tag, I can put these so-called key value pairs. Or, as we'll soon see too, if I want to factor them out and put them into a separate file, I can actually use a link tag, which confusingly has nothing to do with hyperlinks or clickable text, but just links in another file, in this case styles.css, the relationship of which shall be that of style sheet. This is sort of copy-paste stuff that you do, where the only thing you really care about as the developer is the name of the file in which you're putting your styles. All right, let's do this. Let me go back over to VS Code. Close out register.html, open up a new file this time called home.html. And let me purport to make a simple home page for someone like John Harvard. I'll copy paste my boilerplate. I'll change the title here just to be, let's say, home. And then inside of the body of this page, let's do the simplest web page possible for someone called John Harvard. I'm going to say, here's a paragraph of text when John Harvard is going to be the person's name. Here's another paragraph of text. Welcome to my home page will be in the middle of this page. Then a final paragraph of text, inside of which is like copyright C about John Harvard down here. So it's a basic website. It's just 3 paragraphs. It's not going to be pretty, but let's make sure I haven't done anything wrong. Let me close my developer tools, click back, Click home, and there we have it. The simplest of pages for John Harvard. Welcome to my homepage, copyright John Harvard. Let's at least start to exercise some control over this. Let's change the font size and the alignment of the text. So back in VS Code, let's go ahead and add, for now, actually not even a style tag, but a style attribute. I'm going to go ahead here and type in style, quote, equals, quote unquote, font dash size, large, and then text dash align, colon, center, semicolon. And I apologize, but semicolons are back in CSS. Then in my next paragraph's open tag, let's do something similar but different. Font size, colon, medium, for medium text, text, align, colon, center, semicolon. And then lastly down here, let's do style equals, quote unquote, font size, colon, small, because it's the footer, so who cares, text, align, colon, center, semicolon. Strictly speaking, at the last key value pair, otherwise known as a property, you don't need these semicolons, but just for consistency, I'll keep them for that. All right, let's go back to this page, reload, and watch. All of the text a moment ago was left aligned and the same size. Now, it's a little subtle, but it's clearly centered, but it's large, medium, and small, respectively. Even if you've never seen CSS before, what rubs you wrong about this design, though, based on all weeks past? Yeah? Yeah, for every line I've been repeating myself with text align center, text align center, text align center. And if we really want to nitpick, these aren't really paragraphs, right? There's like no phrases or full sentences, let alone paragraphs. So it turns out there's a whole bunch of tags we can use to lay out a page. And in fact, I'm going to transition to one that's a little more generic than paragraphs, namely div, which is just going to create a division in the page for me. And this doesn't have any functional impact, but semantically it's a little nicer because it means I've got the division here for the header, the division here for the main part, and the division down here for the footer. It's just a different way of thinking about it. It's just different rectangular swaths of the page. But I like your point that text align center is kind of stupidly duplicated all of these times. Let me actually go ahead and first reload this change, because there is one side effect that we might want to get back. When I reload now using divs instead of paragraphs, well, there goes the nice white space in between my text. Divs just give me rectangle after rectangle. And as an aside, let me control click or right click, open up developer tools yet again, and notice this other trick with your elements tab. Whatever you hover over at the bottom of your screen will be color coded at the top of the screen. So if I dive into the body by clicking this little triangle, let me zoom in, at bottom left, I can now see my own HTML much more pretty printed and colorful down here. If I click on this one or hover over it, you'll see that the first div, the rectangular region, is highlighted. Now the second, now the third. That's all we mean by divisions of the page. This allows me to see my copy of it in the browser as opposed to in the original file. So just another technique for developer tools. All right, but I don't like this duplication, but here is now the C in CSS. Cascading style sheets means that if you want one property or key value pair to sort of cascade down on all of the other tags inside of that one, you can do that. For instance, in the body tag, I can add my own style attribute here and put all of that text align center there. Why? Because div, div, div are the three children of the body tag, to borrow our vernacular from family trees and from trees more generally. So this too should work, because text align center should cascade down now on all three of those children. And indeed, if I reload the page, nothing visually changes, but it's arguably now better designed. All right, what more could we do here? Well, how about this? It would be nice to make clear to servers out there, like search engines, like what's going on in the page semantically. And the term of art out there nowadays is the semantic web, which essentially is about putting more hints in your HTML so that servers, like search engines, kind of know more so what they're looking at. This is pretty generic right now, div, div, div. But presumably, the top of the page is among the most important things, because that's effectively like the header of the page. Then the middle div is kind of the second most important, because it's like the main part of the page. And the footer is like the least important. So it turns out there are other tags in HTML besides paragraphs and divs. There are literally tags like header, which allows me to define the header of the page, main, which allows me to define the main part of the page, and then even footer, which allows me to define that too. So now if Google and Bing and other search engines are sort of crawling my website once it's public, they know that John Harvard's important because it's in the header. Welcome to my homepage is important because it's in the main page. They're probably not going to care as much about the copyright because it's in the footer. So it's just providing more hints to these kinds of services. Moreover, we can do some other things here. This is kind of a hackish way to implement a copyright symbol. HTML also has what are called entities, where if I can do this magical incantation here, ampersand, hash symbol, 169 semicolon, notice that VS Code recognizes this as an HTML entity. If I go back to this page and notice my first approach was just parenthesis, C parenthesis. If I reload now, having used that HTML entity, which I only know by having looked it up, now I get the copyright symbol that actually comes in the font that's being used here. All right, so let's transition now to this approach, whereby I claimed before that you can actually use a style tag. And why might we want to do this? Well, looking back at my code here, this is sort of hinting at potentially bad design, even though there are different arguments for and against this. Right now, I'm sort of commingling my data with my presentation thereof. Like John Harvard, welcome to my homepage, and copyright such and such is sort of the data I care about. But I'm sort of mixing in the stylization of all of this stuff by putting CSS and HTML in the same place. So to be clear, all of the green stuff and, well, everything we've seen thus far, the tags and the attributes, that's all HTML syntax. Everything between the quotes is now CSS. And this is the first. We've seen this before only in the sense that we've used SQL inside of Python code. Here we're using CSS inside of HTML code. But the CSS syntax is everything thus far inside of those quote marks. Wouldn't it be nice to kind of factor that out so that I can see it all in one place, and better still, factor it out ultimately to another file? And I can do this as follows. Let me, in my home.html, get rid of all of these style attributes and really go whittle the page down to its essence, whereby I just have the header, main, and footer tags, inside of which is that content. It's already easier to read, at least for me, the human. Inside of my head tag now, though, let me go up and say style. And inside of this new style tag, let me show you another approach for stylizing the page. Up here is where we can actually select elements to operate on using what are called selectors. So if I want to modify the style of my page's body, I can do that by typing body. And then, I'm afraid curly braces are back in CSS2. I can put text align center up here. And the fact that I've put the word body before those curly braces just means all of these key value pairs, one in this case, will operate on the body. Meanwhile, down here, I can say the header is going to have font size : large. The main part of the page is going to have font size : medium. And then lastly, the footer of the page is going to have font size : small. You know, definitely more lines now, which isn't the best. But the effect now, if I go back to my browser and reload, visually is pretty much the same. I've just relocated all of those key value pairs elsewhere, but as a stepping stone now for doing something a little smarter, whereby I now can lay the foundation for putting this in another file altogether. But first, let me note this too. The fact that I've put all of these key value pairs associated with specific HTML tags doesn't really make them very usable, or rather reusable. And so when I alluded to earlier that these properties can be applied to different selections of HTML, type selectors, class selectors, ID selector, attribute selector, let's just give you a little taste of this. What do we mean? Well, suppose that I want to generically be able to use text align center without associating it only with the body. Maybe I want to use this for a larger project where I want to center many things on the page. I can define my own keyword, like the word centered, which doesn't exist per se. But if I prefix it with a dot, what I've just created is what's called a CSS class. And a class is just a set of key value pairs, properties, that you can associate with any HTML tags. Meanwhile, if I want this key value pair to be associated with the notion of large, I can define .large, I can define .medium, and I can define .small down here. The motivation for which is that now in my page, if I want to center the body, whoops, let me fix my own typo. If I want to center the body, I can say, please use the class known as centered on this tag. And then on the header, I can say, please use the class known as large on this tag. And then please use the class called medium here. And then lastly, use the class called small here. So now, in the spirit of a lot of the modularization we did in Scratch and in C and Python of making your own functions, classes aren't functions, but they are a way to encapsulate one or more properties and use or reuse them anywhere you want in a web page. It's not that impressive here in this short one, but it lays the foundation for doing much more interesting things soon down the road. In fact, let's take a step in that same direction. Let me go ahead and now highlight everything I've put inside of this style tag and cut it onto my clipboard. I'm going to get rid of the style tag altogether. I'm going to create quickly a new file, com.css, and I'm just going to paste all of that stuff in there. And just to be nitpicky, I'm going to de-indent it so it's all left aligned. So all I've done is just move everything I just wrote into a new file called home.css. I'll close that, out of sight, out of mind. But what I'm going to do now in the head, instead of a style tag which contained all of that clutter, I'm going to say link href equals home.css. And then this rel tag, which just means the relationship of this file to this one, shall be that of a style sheet. And this tag 2 does not need to be closed. It just is. And now if I go back here and reload, still no changes other than tweak the font a moment ago. Still no changes, but now it's better design with that file completely separate. So where are we going with this? Well, just to kind of circle back to something we did earlier, let me open up my terminal window and recall earlier we had this file like favorites0.html, and this contained all of the data from a couple of weeks back that we solicited via that Google form. And recall a bit ago when we went into favorites0.html, I mean, it was just kind of an ugly table structure. But it turns out in the world of HTML and CSS, there are also what we're going to call frameworks, which is a fancy word for library. But a framework is sort of a way of doing something by using someone else's library. And to do it their way, you just read their documentation, and then you adopt their functions in the case of code, or you adopt their CSS classes in the case of this example. So one of the most popular frameworks out there nowadays, and among the simplest and best documented, is one called Bootstrap, which is a set of CSS classes and other features that you can use, because it's open source, in your own code. And in fact, all of the documentation is at this URL here. I read the documentation before class, and I copied really the one line of code that I need to make favorites.html even prettier. So let me go back into VS Code, and let me copy my pre-made example from earlier. And you'll see that in favorites1.html, I have all of the same code, all of those lines of everyone's submissions. But notice I've added now this link tag. And it's a little longer than the one I wrote. It's referencing a third-party website, JS Deliver, which is a CDN, content delivery network, which is to say a server that just serves up content for other people to use. But I copied that from Bootstrap's own documentation. And what I did here is the following. I added a class to my table tag, specifically with a value of table and, followed by a space, table striped. Why? Well, I read Bootstrap's documentation at that previous URL, and I liked the look of their tables because it lays it out with nice stripes like white and gray, and it sort of formats everything quite a bit nicer. So if I go into this version in my second tab by going back first and now opening up favorites1.html, same exact data, 2 lines of change. And voila, now we're talking. This looks much more like a table that you would see on any pretty website like your Gmail inbox or the like, all by simply changing the CSS and not really the HTML at all. So the motivation for introducing those classes a moment ago was so that we can have reusability of code. And better still, we can start to stand on the shoulders of others by using code that other people have written in order to improve the aesthetics of our own websites as well. All right, how about a couple of final flourishes with some style? Let me close out these examples here, and let me propose to go into how about that same link example from earlier. So let me reopen link.html, which recall had this phishing attack at the time. I'm going to revert this to the safe version and just say visit Harvard at Harvard's actual URL. Suppose I wanted to stylize this link beyond the default. Well, let's see what it looks like by default. If I go back into link.html, this is what it looked like before, blue and underlined by default per the browser's decision. But I can override that in any number of ways. To keep things simple, I'm just going to stay in my same file now rather than be pedantic about moving it to another file. And if I want to stylize the anchor tag, just as before, I can say A, and then in some curly braces here, I can do something like this, color, red, if I want to make it crimson-like instead. Let me go back to VS Code, or my other tab, click reload, and now we have a red tab. I can really geek out. And if you remember your hexadecimal codes from our discussion of images a few weeks back, I can do hash FF0000, which is a lot of red, no green, no blue. And if I go back to my other tab, click reload, same exact thing. You have that much control over even the color codes that you might use. Maybe you don't like the underlining in this particular case. Well, that's fine. I can do something like text decoration none per the documentation. I can reload, and gone is that underline. Maybe it'd be nice to hover over the word and then see the underline. Well, I can do that too. Turns out I can have these pseudo selectors whereby I say the name of the tag, then a keyword like hover, which browsers know to recognize. And when I hover over an anchor, what I want to do is change the text decoration to underline temporarily. If I go back to this tab now, reload, looks the same, but as I move my cursor over, notice that it's underlining it for a visual effect. Let's see what's going on with my developer tools. If I right-click anywhere and choose Inspect, notice a detail I haven't showed us before is under the Elements tab here. Notice if I go down to my link here, and let me just make the right-hand pane here a bit bigger. All this time, but ignored up until now, has been this part of developer tools, whereby I can actually see all of the CSS that applies to the element I have just selected, namely this link. And I see here in nice, pretty printed fashion that I'm using this color, FF0000, text decoration none. Why is this useful? Well, one, if you want to learn from another website how it's doing its thing, you can just look at the CSS. But also, if you want to be able to iterate more quickly and just kind of tinker with things, I can actually turn the color on and off by just hovering over the inspector here and just turn it on and off by clicking and unclicking. And if I want to just play around with, oh, maybe Harvard should be 00FF00, enter, I can make it green instead. So you can temporarily change the browser's copy of your own HTML or CSS just to tinker and iterate quickly, just like I tinkered with Stanford's own website, or at least my own copy thereof. Lastly, how about in terms of these selectors? These are using type selectors, that is, selecting the name of the tag. If I want to actually affect one tag specifically, a very common convention is to give an HTML element a unique ID. For instance, I'm going to call this Harvard. And by honor system, I should not give any other element in this page an ID of Harvard. The motivation is that I can now uniquely identify this tag by, for instance, changing this to hash Harvard, which is just the convention for specifying that it's not a class now. It's instead an ID. You do not put the hash, though, in the actual value down here. And what I can even do down here is something like hash Harvard to scope that as well. If I now reload, we're back to the red version and the same functionality as before. And it's just a more precise way now to target your CSS properties to a very specific element instead. Whew. OK, that was a lot. Any questions on any of this thus far? No? That clear? All right, well, one last language for the day. And we do mean what we say. Like, that is the extent to which you will learn formally HTML and CSS. Like, everything else just follows those exact same patterns. It's different classes, it's different attributes, it's different tag names, all of which can be picked up through practice, through osmosis, through references. But that's really it for the fundamentals. And so our last focus today is on an actual programming language that we'll just scratch the surface of, if only because it's so darn omnipresent nowadays. Most every website you use is made from not only HTML and CSS, but if it's in any way interactive, odds are it's using JavaScript, a programming language that is very commonly used client-side, whereby humans write the code on the server, but then your browser, as before, downloads it to the client, and then it runs in your own Mac, your PC, or your phone. That said, JavaScript is also very popular on the server nowadays. It's not just a browser-based language. In JavaScript, what you have most powerfully, though, is the ability in memory to mutate this tree in real time. In other words, think about even your Gmail inbox or your Outlook inbox. Typically, you see email after email after email after email. Odds are, per today, what HTML tag is creating that UI of row after row after row? Which tag? Like table tag. Like the table tag, probably, right? Table row, table row, table row. But it wouldn't make, well, actually, this is the way things used to work in my day. Back in the day when you visited, not even Gmail before it existed, but your email inbox, you would download from the server a web page containing a table tag with table rows and table data elements, and that was your inbox. If you wanted to see if you got new mail, you just reload the whole page, and it would download new contents from the server and show you the new HTML. With JavaScript, though, which has come onto the scene over the past 20 plus years, you have the ability to download the data once initially, then use code to just grab some more data every 30 seconds, or some more data pretty much any time an email arrives. And if this picture here represents not our super simple hello title, hello body page, but a whole bunch of table rows for your existing email, the moment you get more email, you can use JavaScript code to add another node to this tree, representing the table row tag again and again. So in short, with JavaScript, you have the ability to change the tree, otherwise known as the document object model, or DOM for short, dynamically in order to evolve the web page. So let's take a quick tour of what JavaScript does have syntactically, and then I'll just demonstrate some of the capabilities thereof without dwelling today on syntax beyond this. So in Scratch, which is looking pretty good now, you had conditionals which look like this. In JavaScript, it's pretty much the same as C. The curly braces are back, at least for 2 or more lines, but indentation doesn't matter except for the style thereof, as in contrast with Python. If you have an if-else, it's going to look the exact same in C. If you have if-else, if-else, you have the exact same thing in C, different from Python because this was elif in Python. Now we're back more verbosely to else if as in C. Variables in JavaScript. Well, here in Scratch is how you set a variable counter to 0. In JavaScript, there's a few ways to do this, but the most reasonable for now is to let counter equal 0. So you don't specify the type. This is more of a polite way of asking the browser, please let a variable called counter exist and set it equal to 0 by default. Semicolons are back. However, that's not strictly true. Browsers are smart enough to know where semicolons actually matter. But for our purposes, assume that they're always there. How do you change counter by 1? Well, you can do it the pedantic way, which is a little verbose. You can do the plus equals trick, or nicely, back in play is the plus plus in JavaScript, just like in C, but not in Python. Loops in JavaScript. Well, in Scratch, if you want to do these 3 times, here's how you would do it in JavaScript. It's pretty much the same as C, except for not mentioning the data type. Instead, you use the keyword let here. But otherwise, this is exactly the same as in C. If you want to do something forever, for whatever reason, in JavaScript, you can say while true, which is exactly how we did it in C. If you have a web page like this, meanwhile, and you want to insert some JavaScript to it, you can do it in a few different ways. You can put a script tag, just like the style tag in the head of the web page. This can get you into trouble, though, for reasons you might encounter, whereby if you put your JavaScript code up here and you try to use it to modify the web page, but the web page isn't defined until down here, you can get into some a race condition, really, where the data does not yet exist. So you, instead of putting it there or even in another file, it's actually pretty common to avoid that altogether by putting your script code or your script tag at the end of the page, just before the end of the body, to ensure that all of the web page exists already. This is similar in spirit to the def issues we saw in Python or the prototype issues we saw in C. There's bunches of solutions, though, to this here problem. But let's now take some JavaScript for an actual spin and use VS Code to write some of it as follows. In VS Code, let me go ahead and close link.html, open up my terminal temporarily, and let's improve let's just improve the very file hello.html that I have here in front of me, and actually have it be more interactive and give me sort of a pop-up on the screen when I type in my name. So let's start as follows. First, let's go ahead and change this just to hello, just for short. And in the body of this page, let's give myself a form. And in this form, let's give myself an input. We'll turn off autocomplete just to avoid distractions. We'll turn on autofocus to save me a click. I'm going to give this HTML element an ID, uniquely of name, a placeholder also of name, just so the human knows what to do, and the type of this field shall be text. In other words, I want to create a program a la week 1 and week 0 where I type in my name and see hello such and such. I'm going to give myself an input, a submit button with input type equals submit. Don't really care what the button says, but I do care now. When I go back to my other tab, close my developer tools, go back into hello.html, I now have something that looks like this. It looks similar to our search example for cat, but now I'm asking the user for their name along with the submit button. But what I want to have happen is when I type in David and click submit, I want to see hello David somewhere on the screen. Well, how can I do this? Well, a few different ways, but JavaScript allows me to do things like this. And for upcoming problem sets, you won't necessarily have to write JavaScript like this. So consider this a whirlwind tour, not so much something to ingrain. Here, I can add a new attribute to the form tag called onSubmit, which, as the name suggests, means call the following function when this form is submitted. Well, what function do I want to call? I'm going to call it a greet function, and that's it for now. How do I define a greet function? Well, I could, among other places, put this inside of the head of my page in a script tag. I can define a function in JavaScript by literally saying function, and then the name of the function, and then in parentheses, any arguments there too. I'm not going to have any. And then in curly braces, I can actually define the meat of that function. And for instance, I can do this. Let name equal the following: document.querySelector. And now what I want to do is this. Document is a global variable that just comes with JavaScript in the browser that allows me to write code involving the whole document, the web page itself. QuerySelector is a fancy name for a function that lets me select specific elements of the page using CSS selectors. So the very same syntax we saw with names and with dots and with hash symbols a moment ago are back in play for JavaScript here. So if I want to create a variable that stores the name that the human typed in, what I can do is pass to QuerySelector a selector for that element, which is quote unquote hash name, where hash just means ID. But the reason I'm using name is because the unique identifier I put here is name. If I change this to foo nonsensically, that's fine. I just have to change this to foo up here. So I'm in full control over what is called what. But if I want to get the value that the user typed into that box, I now do value. And we've seen these dots before. In C, they were for accessing structs. In Python, they were for accessing contents of objects. So this just means use the document global variable, use the QuerySelector function or method inside of it, get the element whose unique ID is name, and then go inside of that text box and give me its value. So it's a very long-winded way of saying store the user's input in a variable called name. But what's nice now, even though this is going to be a bit ugly, is I can then use a built-in JavaScript function called alert, and I can say something like hello, comma, close quote, then plus, which we've seen before in Python, and concatenate with it that name's value. Now, this isn't quite complete, and for reasons I'm going to wave my hand at, I also need to add, annoyingly, return false down here, because otherwise, if I click submit, yes, the greet function will get called, but the browser will still try to submit the form to a server, which is going to interrupt my own code. So long story short, this is a bit of a hackish approach for now to just making sure that the only thing that happens when I submit this form is that my function is called. Now, if I didn't screw anything up, I should now see, after reloading this page, a prompt for my name. I'll type it in, and when I click submit, I should see an ugly but functional alert box pop up with dynamically generated text, namely hello, comma, David. I say it's ugly because by convention, Chrome shows you the full URL or the domain name of the website in question, which is my randomly generated one, which does look stupid. So we can do better than this. But the point is now that I have written code in JavaScript to listen for the submission of this form, and when that happens, call that their function. And this is generally the paradigm of JavaScript. There exists in the context of websites a whole bunch of events that can happen. And this is a word we haven't used since week 0 in Scratch. Recall that in Scratch you have events like when green flag clicked. And when the green flag is clicked, you can do something in response. Same thing in the world of web programming. Here are just some of the events that can happen in a web page. Like the user can change something, click on something, drag something, key up, put the keyboard up, put the mouse down, or other things. What I'm listening for is the submission of a form, which is cool because in JavaScript then, you can essentially write code that listens for any number of these events and then does something when it happens. Consider, after all, in Gmail, if you click the little refresh icon within Gmail itself to get new mail, it runs some JavaScript code, it turns out, to talk to Google's servers, get more email, and update your site. If you click and drag on Google Maps to see like higher up geographically, well, what's happening? Some JavaScript code is listening for your mouse going down and dragging so as to go fetch more tiles, more rectangular pictures of the map wherever you're trying to drag. So anything that's interactive in websites nowadays like that is using JavaScript by just listening for things that you or someone else might actually do. Well, let me go ahead and start opening some pre-made examples just to give you a sense of the other syntax that is in use today with JavaScript. I'm going to go ahead and open up a version of this hello program called hello2.html, which is different in that I'm practicing what I preached earlier by putting the script tag at the bottom of the page just to ensure that the form and everything inside of it already exists for sure by the time this code executes. Moreover, what I'm getting out of is the business of using the onSubmit attribute. So just as I tried to get my CSS out of my HTML and put it elsewhere, similarly, I'm trying to get my JavaScript code, like the greet function, out of the HTML and putting it down here. Now, why is this useful? This is a big mouthful, but it just follows a general pattern as follows. Document.querySelector, quote unquote, form, is just getting a reference to the actual form element in the page. So if you imagine in your mind's eye that this is drawn out as a tree in the computer's memory, this is just getting me a pointer to the form node in that tree. Haven't seen this before, but it kind of does what it says. Add event listener is a function or method that you can call on any element that just tells it to listen subsequently for this event. And when that event is heard, submit in this case, call the following anonymous function, otherwise known as a lambda function. But long story short, this syntax just means when submit happens on that element, execute the code between these curly braces. What happens? Alert, hello, quote unquote, document.querySelector name.value. I didn't bother with the variable this time. This does exactly the same thing, but is a purely JavaScript solution without using the onSubmit attribute. And we show you this only because, especially for final projects, you might want to do something like add event listener to make like maybe a drop-down menu or some interactive clickable thing in your website that just listens for one of these events to happen before actually executing some code. Notice I've been conventionally using single quotes in JavaScript because that's just a thing in the JavaScript community to generally prefer single quotes over double quotes. Why? Well, it means people in JavaScript are hitting the shift symbol like much less than the rest of the world to get double quotes. It's just a convention. So long as you're consistent, either is fine, conditional on not having actual apostrophes in text and such. Let me show you one other convention. Instead of putting my code at the bottom of my page just before the body ends, it is also alternatively conventional, as in hello3.html, to do this. To still maybe put the script tag at the top of the page, but to additionally have this magical line, whereby you add an event listener before you do anything else that listens for this crazy, weirdly named event called DOM content loaded. But now that you've heard DOM briefly, DOM is document object model, it just means the tree in memory. This is just a fancy way of saying when that tree is loaded, go ahead and do the following. And this ensures that when a browser reads all of this code, top to bottom, left to right, this code won't actually be executed until the whole DOM is loaded into the computer's memory. That whole tree is built. So that's all that's being referred to there. The rest of the code is actually exactly the same. What more can we do? Well, just so you've seen it, I can delete all of that code, move it to a file called like hello.js. And in the fourth version of this example, I'm back to just HTML because I can put all of the fancy complexity inside of my script tag here, factoring that code out into hello4.js. But the code is otherwise, I claim, unchanged. All right, this is a lot. I know. It's quick. But do the general principles make sense? Like just listening for events and running some code in response. That's really all we're talking about a la week 0 with Scratch. All right, well, let me let things escalate just a little bit. And this time I'll open the demo first. Let me go ahead and open up hello5.html, which I wrote in advance, which, OK, is definitely starting to look like a mouthful. But in a moment, it'll make a bit more sense. Let me go ahead into my other tab here, click back. Go into source 8, which is all of my pre-made examples. And I said we're in hello 5 now. And in hello 5, there's no submit button because watch this fanciness. When I search for something like C or David as a full-fledged word there, notice it's just happening inside of the web page. Moreover, if you poke around, let me right-click on the page. Let me inspect to open my developer tools. Let me expand the body down here. And actually, let me reload the page. So notice, by default, this is what my web page looks like. It's just got an empty paragraph tag for some reason. But watch what happens at the bottom of the screen. And I'll zoom in a bit more when I start typing my name like D. And then let me expand this triangle. You see it beginning. A, V, I, D. When I say that JavaScript can mutate the DOM, the actual tree in memory, like that's what you're seeing. You're seeing the HTML pretty printed, color-coded version of that tree in memory. And how is it working? Well, if we go back to the code here, well, let me wave my hands at this first line. This just means don't do this until the whole DOM is loaded. Let's look at this line, which means give me a variable called input and set that equal to, OK, the input tag on the page, the text box. And then do what? Well, take that input, add an event listener that's forever listening for key up, like my finger going up off the keyboard. And when that happens, call the following function, which has no name, but that just means call these lines inside of the curly braces. Well, what happens inside of those curly braces? Well, here's a variable called name, and this is just pointing at the paragraph tag, apparently. I'm checking this question if there's, if input.value. So this is like saying if input.value does not equal quote unquote, just implicitly, go ahead and set the inner HTML of that name variable equal to hello, quote unquote, input.value. Now, this is crazy syntax, and I'm showing it just because you'll see it in documentation online. This is similar in spirit to Python's f strings. It's ugly syntax with $signs and curly braces and, worse yet, backticks. However, this is a manifestation of really the JavaScript community presumably deciding that if you want the language to evolve, you have to make sure you're backwards compatible with old versions of the language. So they chose characters in syntax that probably do not appear already in the wild. That's why sometimes things look uglier, I would surmise, than otherwise. But long story short, this just means if there's input there, go ahead and say hello, comma, input. Otherwise, it says by default, hello, whoever you are. And in fact, if I go back here and delete my name, watch what happens. It goes back to that default. So here's just an example of listening for keystrokes going up and down and making sure that the page responds accordingly. How about something else? Let me go back into my directory listening. Let me open up background.html, which I wrote in advance. It's super simple, but this is the first of like an interactive website that has 3 buttons labeled R, G, and B. As you might imagine, clicking on R does that. G does this. B does that. Well, how is this working? This is the first example now where you can use JavaScript code to alter CSS dynamically. So let me reload the page so it's back to white. Let me open Developer Tools. And watch what's happening now on the body tag specifically. Initially, there's no stylization on the body other than the browser's default margins and whatnot over here. But watch what happens at bottom right when I click on the R button. You see that all of a sudden, background color, :red, was dynamically added. Now it's green. Now it's blue. And notice the HTML at bottom left is changing too. So somehow I am listening for clicks and then changing CSS in response. So if I go back to VS Code, let's close Hello 5. Let's open up Source 8's version of background.html. And in here, it's a bit of a mouthful, but the HTML is simple. Here's 3 buttons. And because I wanted them to be uniquely identifiable, I gave them all IDs of red, green, and blue, respectively. And then this code is a bit of copy-paste. And frankly, I could probably avoid that if I were more elegant. But just to be pedantic, here's what's happening. Here's a variable called body that's just getting the body element, the node in the tree at that moment in time. And then these 3 lines of code, their purpose in life is to handle the red clicks. How? Well, we're telling the document to select the element whose ID is red, listen for the click event, and whenever that happens, do this. Body, which is the same variable as before, .style, which we haven't seen before, but any element can have a style property associated with it in JavaScript. Background color equals quote unquote red. And the other blocks of code are exact same thing for green and for blue. The whole point here is we're now listening for clicks on buttons and changing not the contents of the button, but rather the style thereof of the whole page. As an aside, this is curiosity. This is what's known as camel case, whereby like a camel has a hump in the middle. This word has a hump in the middle, like capital C, all of a sudden, to separate the 2 words. In CSS, recall, it was, a moment ago, background dash color. Anyone want to guess why this is not how you write it in JavaScript? Anything with hyphens in CSS is changed to camel case in JavaScript. It's not related to comments. It's simpler than that, yeah? Yeah, right. Like left hand wasn't talking to right hand, and people were like, oh, damn it. Like this now means background minus color, which is not a thing because minus is indeed, just like in C and in Python, a mathematical operator. So the world decided to reconcile this problem by just capitalizing the character that would otherwise be where the hyphen is. So little CSS trivia. All right, what else can we do? How about a couple of final examples here. So what more can we do with CSS? So back in my day too, we had a tag called the HTML blink tag, which is among the few tags in the world of HTML that has actually been deprecated. That is removed from language. Like no one removes things from languages generally, but the blink tag was so hideous, followed only by the marquee tag, whereby my own homepage, just like a freshman, had like welcome to my homepage just moving across the screen like this from left to right for no good reason, like an ugly marquee and like on like a digital signage nowadays. But we can bring it back as follows. So if I close out my developer tools, go back into my source8 directory and open up blink, this is what the blink tag used to do back in the day. Now this version is implemented instead in JavaScript code as follows. I have a function here called blink, which I'm apparently calling every once in a while. How is that happening? Well, let's scroll down. Here's my HTML, super simple, literally just says hello world. But notice this. There's another global variable we haven't seen in JavaScript called window that refers to like the general window, not necessarily the contents of the page, where you can call a method called setInterval, and you can tell that method, setInterval, to call a specific function every number of milliseconds. So if I want to call blink every 500 milliseconds, that's the line of code that I use. If I scroll up to now this function, let's see how blink is implemented both now and perhaps back in the day. Well, body is a variable here that's just pointing to the body node in the DOM. And this is a big mouthful, but if that body's styles visibility property in CSS is quote unquote hidden, then change that body's styles visibility property to be visible. Otherwise, change it to be hidden instead. Here too, don't understand why left hand and right hand weren't talking to one another. You would think that the opposite of visible would be invisible, but in CSS, the opposite of visible is hidden. Just have to memorize stupid things like that. But what's this really doing? It's just changing the CSS from hidden to visible every 500 milliseconds. So in fact, what you're seeing here in the blink is if I inspect this page too, and now notice, it's kind of fun just to watch it, you can see the HTML at bottom left and the CSS at bottom right just automatically changing because I'm doing that every 500 milliseconds. All right, how about one other? Well, autocomplete. Well, we saw a step toward this with my hello, David example a moment ago. Super common, though, in Google and like every website now to automatically try to finish your thought. How is that happening? Well, that's not just HTML and CSS. That is also some JavaScript thrown into the mix. So for instance, let me go into my terminal and open up source8's example called autocomplete.html. And here I am going to borrow a file called large.js, which is just a massive version. I'll open that too if you're curious. Large.js is just a huge JavaScript array, arrays are back, containing all of the words from problem set 5, the spell checking problem set, where you had 100,000 plus words in a file given to you. Now we've converted that to JavaScript by using a global variable like this. In the code here, what's happening? Well, apparently there's going to be a text box at the top of the page that we see. Then there's an empty unordered list, so an empty bulleted list. And then there's this code down here. I'm apparently creating a variable called input that's referencing that text box. I'm then listening for key up, just as like we've done before. And then I'm doing this. I'm setting a variable called HTML equal to quote unquote nothing, so an empty string. And then I'm checking, does the input text box have any value implicitly? If so, what am I doing? This is kind of cool. It's a bit of Python and C together syntactically. For each word in the words array, JavaScript uses the keyword of instead of in, like Python, but so be it. What I'm doing now is in JavaScript, I'm saying if that current word in that big file of 100,000 words starts with whatever the user typed in, go ahead and add to that HTML string using plus equals, which is just concatenation. We've seen plus before, the following. An li tag inside of which is that specific word. And so in effect, what you're seeing now is what almost every website nowadays does. They're not manually writing HTML like we've been doing much of today. They're writing code that dynamically generates HTML because the programmers understand what HTML is. They understand that unordered lists have li children. And so using this string that I've highlighted, they're creating li element after li element for the purpose of changing the inner HTML of the UL element to be the value of that variable. And this is a very long way of saying how is autocomplete implemented in general? Well, just like this. If I search for cats by typing in C, there's every word in that 100,000 dictionary that starts with C, A, T, S, and there's every word that starts with CATS. Meanwhile, watch what happens underneath the hood. If I open up my Inspect tab again and I go to my body, inside of this is the empty UL. But watch, as soon as I start typing something like C, now I can expand the triangle because there is an LI element that's been created for every one of the words that match. As I do ATS, now I've got just 4 of them. And there is cats, there is catskill, and so forth. So anytime you go to google.com like we did earlier, we went to google.com and started searching for CATS. Where are all of those search results coming from? Someone wrote JavaScript that's listening for key up or the like, and then dynamically populating an unordered list, or in this case, a much prettier list of the matching results. And the final example that we thought we'd leave you with, and again, the whole purpose of introducing JavaScript is to give you a taste of its syntax and its relative familiarity, but with the power that you can, the power with which you can leverage it to make websites so much more interactive. And in fact, with Bootstrap, you don't just get CSS you can use, you have a whole set of JavaScript functionality, so you can have drop-down menus and the like. For instance, among the things you'll use for an upcoming problem set and perhaps your final project, something that looks a little like this. In bootstrap.html, here's a whole bunch of code that I literally copied and pasted from Bootstrap's documentation. And it's just like boilerplate code for a corporate website that has features with pricing and disabled menu options as well, just for the sake of discussion. And then here, if I go back into this example, you'll see fairly simple website that looks like this, a so-called nav bar with all of the main menu options of like a corporate website. And notice if you start to resize the window, which I'll do here, and put it into sort of mobile mode because it's so narrow, now thanks to JavaScript, it's listening for clicks on this hamburger menu and revealing the menu options that way. This is quite like how CS50's own website works and so many other websites out there. But the last one we thought we'd use is you're so in the habit of using Google Maps or Uber Eats or any number of apps that need to know your location. That too is exposed through JavaScript quite simply. Let me go ahead and in geolocation.html open up the following code whereby, super simple, even though some new functions, there exists another global variable in JavaScript in browsers called navigator, which has a property called an object called geolocation, which has a function called getCurrentPosition. That takes an argument, which is just an anonymous function, which means call this code when you're ready to know the coordinates, because it might take a while to figure out your GPS coordinates. And once you do, this simple example is just going to write to the document, that is the rectangular page, the position's latitude that comes back and the position's longitude that comes back. So to see this in action, let me go ahead and open up that second tab, go back into geolocation. It's notice for privacy's sake, it's asking me to approve this. So I'm going to say allow this time. There are apparently my laptop's GPS coordinates. And if I go to googlemaps.com, I can actually paste this in here, enter, and looks like if we zoom in. OK, I'm not technically outside, so it's only close to a degree of precision. But it's probably mapping to one of the Wi-Fi access points that's on that corner of the building. So we're pretty darn close, pretty much close enough to get me my food or my ride here. And a final note, now that you've seen a little bit of JavaScript, let me go ahead and open up just 60 final seconds of just how much effort it took us to put not only this lecture together, but particularly that example of the teaching fellows passing packets. Everything we like to think is very finely flourished here. But here's a little bit of behind the scenes in these final 60 seconds together. If we could dim the lights before we adjourn. Nothing good? Buffering? OK. Josh? Nice. Ellen? Oh! Moni. No, oh, wait. That was amazing, Josh. Sophie? Amazing. That was perfect. Moni?
I think
Over to you, Al.
Oh, nice.
Guy? That was amazing. Thank you all.
So good.
All right. That's it for CS50. We'll see you next time.